Alright, I think we're live. Let me see. I think we are. Right? Yes. Yes. Okay. Let me take a look at the scripts and change the timer. Time it to around 300 seconds. So 300. Then close. Okay, we're good. I'm just gonna edit this text because we're no longer taking a break. Well, I guess I'm not gonna use that screen. Yeah, so never mind. Never mind. I think I can just leave it like this. Alright, so in the meantime, while everybody arrives here to the stream, the morning has just started for me. And so, yeah, it's all right. So today we're going to be taking a look at the Bitcoin white paper. Then we're going to be learning Rust as usual. I'm very excited to take a look at the Bitcoin white paper because we were reading it, and then in the middle of it, we got sort of into this little sub-branch, which was learning about cryptography, right? So sort of learning everything about cryptography that we needed. And then after that, we, actually started working in the book, JOC, the Joy of Cryptography book. We read all the chapters that were necessary for us. And so now we have enough knowledge to be able to tackle the white paper better. I think a 20-minute explanation of what asymmetric key cryptography is would have sufficed, or how signatures work. But I think, the fact that we went out of our way and sort of tried to learn actually what was involved in the process of, the cryptographic process behind signatures was very productive and something I do not regret at all. So, yeah. All right. So, let me transition here. So, as usual, our first part of the stream is going to be reading the white paper. The second part of the stream is going to be Rust, right? Learning Rust. And I think today, I'm willing to say, we could start our cryptography module, which is great. So, actually, I think we just gotta complete Rust links, but that's fine. So let me go here to Firefox. And I think the Bitcoin also, what is the price of Bitcoin right now? I feel like I've been so out of this world. Oh, it went up by a lot. Who knows? Let's look at the Bitcoin white paper. Take a look. All right. I don't know why, but I'm feeling so sleepy today. For absolutely no reason. Oh dear. Give me a second. I'm going to set everything up. Yes. Okay. Perfect. I think that's the ideal size, yes. Alright. So, oh, the Ferrari, hello. Is it just you? Oh, yes. It is really quiet because yesterday, there you go, I think that fixes things. Yesterday Andrew was saying that, it was very loud. So, yeah. How are you? How are you today? Yeah. It's tomorrow is your return. Tomorrow is the end of vacations. Pretty for everybody, yeah. Too much better. Okay. Pretty good. Ah, alright. But yeah, I was here just explaining that. Given that we finished the Joy of Cryptography sort of chapters that we needed to take a look at, we're now going to proceed to take a look at the actual Bitcoin white paper, the original sort of origin of the idea, which is surprisingly only 9 pages long. Like, I personally cannot believe that. Like, 9 pages, and the last one is references, so it's only 8. And these last 2 pages talk about, well, actually, kind of 3 pages, or 2 pages talk about calculations. So the actual paper is only like 6 pages. 1, 2, 3, 4, 5, and 6. Just absolutely insane. So, yeah. As usual, first part of the stream is going to be just reading, learning. So this is going to be, once again, more like an audiobook. I think we can read the entire white paper today because it's really, really short. So, yeah. Let me get some water for this so that I can read it better. There you go. Alright. Let's begin this beautiful Thursday morning. So it says, Bitcoin, a peer-to-peer electronic cash system, by Satoshi Nakamoto, satoshi@gmx.com, www.bitcoin.org. Abstract. A purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. Digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent overspending. Perfect. So we know that the problem of saying, am I sending the money to the right person, is something that digital signatures already solves. You do not need a third party to verify this. You do not need your bank to tell you, yes, indeed, this is the real, Daniel. You can just use the concept of digital signatures for this. So, perfect. But it seems there's still the problem of double spending. Somebody could send, they only have $100 in their account, and they could create a transaction that says, send 100 to Daniel and send 100 to Eliza, right? They just sort of emanated $200 despite having only 100. Of course, Daniel and Eliza don't know each other, so they cannot know this. So this would be the problem of double spending. Hi, Kamal. Welcome to the stream once again. And yeah, today we're reading the Bitcoin white paper since we finished Joy of Cryptography. And we just started with the abstract. We propose a solution to the double spending problem using a peer-to-peer network. The network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. Okay. The longest chain not only serves as proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. As long as a majority of CPU power is controlled by nodes that are not cooperating to attack the network, they'll generate the longest chain and outpace attackers. The network itself requires minimal structure. Messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will, accepting the longest proof of work chain as proof of what happened while they were gone. Introduction. Commerce on the internet has come to rely almost exclusively on financial institutions serving as trusted third parties to process electronic payments. Hi, Penguin Operator, welcome to the stream. reading the Bitcoin white paper. Um, hmm, this is interesting. Give me a second. I need to respond to something here real quick. Um, sorry. Um, da, 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 da. Yeah. Okay. All right. Commerce on the internet has come to rely almost exclusively on financial institutions serving as trusted third parties to process electronic payments. While the system works well enough for most transactions, it still suffers from the inherent weaknesses of the trust-based model. This little phrase, commerce on the internet, has come to rely almost exclusively on financial institutions serving as reads to me as like, like the industrial revolution and its consequences have been a disaster for the human race. Like the first, it reads almost like a manifesto. Like commerce on the internet has come to rely almost exclusively on financial institutions serving as trusted third parties to process electronic payment. I guess right. I guess Bitcoin is a sort of manifesto, like this white paper. But yeah, while the system works well enough for most transactions, it still suffers from the inherent weaknesses of the trust-based model. Completely non-reversible transactions are not really possible, since financial institutions cannot avoid mediating disputes. The cost of mediation increases transaction costs, limiting the minimum practical transaction size and cutting off the possibility for small casual transactions. And there is a broader cost in the loss of ability to make non-reversible payments for non-reversible services. Okay, so we have cost of mediation increases transaction costs. So we have fees are a problem. Limiting the minimum practical transaction size. So minimum transaction size, which I don't see that as a strong point, but that's okay. And cutting off the possibility for small casual transactions. Okay. And there is a broader cost in the loss of ability to make non-reversible payments for non-reversible services. So this is another one. Non-reversible payments for non-reversible services. These are a problem. I think like possibility for small casual transactions. Like this is solved in the modern world, I would say, right? Say platforms like Venmo, where you can just share 1 cent with another person. Cost of mediation, the minimum practical transaction size. This also, I feel these two are solved in the modern world. Maybe it was different back then in 2009. Or maybe, Satoshi's referring to something else. But yeah, I think the fees and the impossibility of having non-reversible transactions, good points. With the possibility of reversal, and of course the overall underlying sort of main point of like, we don't want our financial system to rely on a single institution or a single, group of institutions. With the possibility of reversal, the need for trust spreads. Merchants must be wary of their customers, hassling them for more information than they would otherwise need. So another point, privacy. A certain percentage of fraud is accepted as unavoidable. These costs and payment uncertainties can be avoided in person by using physical currency, but no mechanism exists to make payments over a communications channel without a trusted party. Okay, yeah, that makes sense. What is needed is an electronic payment system based on cryptographic proof instead of trust, allowing any two willing parties to transact directly with each other without the need for a trusted third party. Transactions that are computationally impractical to reverse would protect sellers from fraud, and routine escrow mechanisms could easily be implemented to protect buyers. So we had read this section before, and we were saying how, this does protect the seller. This sort of doesn't protect the buyer. Because routine escrow mechanisms can solve the buyer's problem, right? Imagine if I said, oh, yeah, routine escrow mechanisms could just protect the sellers, right? And it's very likely it would say, like, no, like, what the hell are you talking about, right? The whole purpose is to also protect the seller. So, I don't know, it seems like a rather, like a little escape. I guess you cannot protect the seller and the buyer at the same time. In this paper, we proposed a solution to the whole spending problem using a peer-to-peer distributed timestamp server to generate computational proof of the chronological order of transactions. The system is secure as long as honest nodes collectively control more CPU power than any cooperating group of attacker nodes. Transactions. We define an electronic coin as a chain of digital signatures. I'll be back. Okay, penguin operator. Define an electronic coin as a chain of digital signatures. Okay. Each owner transfers the coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner and adding these to the end of the coin. A payee can verify the signatures to verify the chain of ownership. Okay, this seems very reasonable, right? So we have transaction. Owner wants public key. Then this hash, okay, and then owner zero's signatures. Okay, how does this diagram go? Owner 2's public key. Hash, owner 1's signature. What is this diagram? Let's see, so owner 1 starts. The coin is transferred to owner 2, right? And the way that happens is owner 1 grabs the whoa. Let's see. Valley, welcome back. I got massive whiplash from reading the place with the first citation. Very mundane and reasonable. And then reading the actual citation, which is insane. Completely out of touch with reality. What do you mean? What do you mean? Wait, whiplash is like surprise, right? Whiplash. Definition. I'm sorry guys, like, please remember I'm not originally, my main language is not English, so sometimes whiplash means caused by fast, sharp back. Yeah, so I imagine it's just surprise, right? Whiplash, reading the place with the first citation, very mundane and reasonable, and then reading the actual citation. Yeah. But what do you mean, like, the first citation, the place with the actual citation? Which citations? Are they at the end? These ones? I'm not sure. Yeah. Okay, in the meantime, I'll continue trying to understand. You haven't got to it yet. Oh, okay. I thought you were referencing something that I was like reading already. Okay. Perfect. So now I'm interested. Wait, I got massive whiplash from reading the play with the first citation and then reading the actual citation. I see. So I imagine that this guy, this reference number 1, it's gonna be like, oh, this is very reasonable, and then the guy that actually, the actual reference is like crazy, but yeah, that's interesting. Let's see, transactions. So let's understand this diagram. We have the transaction here. So owner 1 transfers ownership to owner 2. How is that done? So each owner transfers a coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner and adding these to the end of the coin. So the thing is, owner 1 then we need to transfer the coin by signing a hash of the previous transaction. So it grabs the hash of owner 0, right? Adds the public key of owner 2, right? And then, because I am not on it, okay, this diagram is a little confusing, but because there's so many arrows. Owner 1's private key, owner 1's signature. Yes, okay. So what is it that you need to sign? Digitally sign in a hash of the previous transaction and the public key of the next owner. So shouldn't this guy be over here? Oh, I guess. Oh, never mind. Whoa, 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 whoa. What am I even talking about? No, this makes total sense. This diagram is very well constructed. The transaction block. Okay, yeah. This whole thing is a transaction. Oh my god, dude, I cannot read a paper. Yeah. Okay, so a transaction is composed by the public key of the next owner. Okay, I see. So this would be like the transaction that owner 0 created, right? This would be the public key of owner 1. Then it would have the hash, right? So these two together. And then owner 0 signs that transaction, with this guy coming in and this guy coming in. And that is what generates sort of the proof that this has been transferred to the other owner, right? Then owner 1 transfers ownership to owner 2, and it does it by attaching owner 2's public key, which is their sort of identifier, the hash of that previous transaction that they have, and then sign in everything, right? Okay, perfect. So owner 1 has the private key. They can sign this perfectly. And then, okay, yes. And then you can just take a look at this hash, look at the previous transaction, take a look at owner 1's public key, verify the signature to know that it was actually owner 1, and so on and so on and so on. Okay, this makes a lot of sense. Right? Perfect. It's like a linked list encoded to a yeah. I understood the concept here. I was confused by the diagram because there were so many arrows, and I thought this was like owner 1's perspective, owner 2's perspective, owner 3's perspective. It's more like this is the transaction that owner 0 created. This is the transaction that owner 1 created, and this was the one that owner 2 created. So that's what confused me. But yeah, let's see. The problem, of course, is the payee can't verify that one of the owners did not double spend a coin. Okay, so we could see a situation where owner 1 emits this transaction that says, yes, I transfer the coin to owner 2, but then owner 1 could just create a different transaction that has the exact same hash, referencing the previous one. It's just that now the owner is a different person. So now they sort of like branch off the entire linked list. And that's a problem, because how do we know which one is the actual one? How do we prohibit people from double spending? So that's an interesting problem. The problem, of course, is the payee can't verify that one of the owners did not double spend the coin. A common solution is to introduce a trusted central authority. Okay, so here we get the justification. Why do we need a bank, right? Or a mint or a central authority to prevent double spending? You need sort of like an all-seeing eye that's able to detect whether or not two transactions refer to the same previous transaction. So I see. So you need a sort of all-seeing eye to realize double spending occurred. Or maybe you don't need an all-seeing eye. I imagine that's exactly what this paper is going to expose, but for now it seems to be the more common solution. A common solution is to introduce a trusted central authority, or mint, that checks every transaction for double spending. After each transaction, the coin must be returned to the mint to issue a new coin, and only coins issued directly from the mint are trusted not to be double spent. The problem with this solution is that the fate of the entire money system depends on the company running the mint, with every transaction having to go through them, just like a bank. We need a way for the payee to know that the previous owners did not sign any earlier transactions. For our purposes, the earliest transaction is the one that counts, okay? So we don't care about later attempts to double spend. The only way to confirm the absence of a transaction is to be aware of all transactions. In the mint-based model, the mint was aware of all transactions and decided which arrived first. So this is a fundamental distributed computation problem. Like, let me see. I think what causes the problem with double spending is because everything is immutable. So spending something, which is the same as building upon, can't change it to be obviously unspendable. I think not. Oh, think. Yeah, of course. But yeah, this makes a lot of sense. But this also, I feel this specific phrase, right? We need a way for the payee to know that the previous owners did not sign any earlier transactions. For our purposes, the earliest transaction is the one that counts. So we don't care about later attempts to double spend. The only way to confirm the absence of a transaction is to be aware of all transactions. In the mint-based model, the mint was aware of all transactions and decided which arrived first. This has like parallelisms with distributed computing, where you have a distributed system, right? And people are submitting sort of operations to it, be it, operations defined however you want. But since it is distributed, often you need to determine an order, right? What is it that I apply first, and how do I make the machines agree on the order? The mint-based model is sort of this primary backup model, right? Where every single transaction goes through a single computer, and then you're able to, nonetheless, that introduces a single point of failure, right? As we know with distributed systems. So then we got in distributed systems like Paxos, right? So it's kind of fun to see, like, this is sort of a very similar problem. It's just that now you have to involve the entire world, right? It's a distributed computation with every single computer in the world. And they all gotta decide what they're going to do. So, an interesting thing here, like, could you use Paxos for this? My intuition would be yes, right? Because this is fundamentally the same problem that, like, Paxos is trying to solve. Of course, you cannot just say, like, put some Paxos in it and it works. Like, I imagine that, like, it's not going to be as easy as that. But maybe you could use Paxos concepts to be able to, to do something like this. I don't think Paxos is meant. That is true. That is true. One of the fundamental things is Paxos is cooperating based. Could you maybe, like, because one of the things that okay, yeah, that is true, right? You need cooperating nodes for Paxos. So you can maybe, like, threaten the nodes, right? Like, if you make a small mistake, you get destroyed or something like that. I guess, like, how would you detect that somebody did something wrong in the Paxos model so that you're able to then threaten them? I think it's very, it's very difficult. Cryptocurrencies are based on what's called Byzantine fault tolerance, which means they have to handle other computers acting maliciously rather than just failing to respond. Yes, this is true. Whoa! Jasper, hello! Welcome to the stream. Thank you very much for the raid. Welcome, everybody. Yo, this is insane. Yay! Okay, Jasper, did you start your billion Merkle tree problem? This is something we are excited to know about. Let us know how the stream went today. Yeah. So welcome to all the raiders. Hello. Today we are reading the Bitcoin white paper because we finished sort of the chapters that we needed to know about and the joy of cryptography. And so now we're taking a look at the fundamental ideas behind Bitcoin and how it was created. Yeah, yeah. So we are discussing here with Valley 2454 whether or not you could use Paxos for this in some way or another. I think, right, of course, like Valley pointed out, it's something very important. Paxos requires all nodes to be cooperative, so of course we cannot. Um, but yeah, Byzantine fault tolerance is what we're gonna be looking at. Hey, not yet, but I'm working on formalizing it and building the tools for generating the data and testing the output validity. Oh, okay. Pretty good, pretty good. Oh, excellent. But yeah, hopefully today's stream went well for you. Yeah, I woke up like a few minutes ago and then it says streaming, so it's very good to enjoy. But yeah, that's pretty good. All right, I think we're gonna continue. Let's read. Let's continue reading. So let's see. We need a way for the payee to know. Oh wait, last streams I implemented chapter 56 and we are beating all of the libs. I tried to open as I remember when we were like, wait, how are you like somebody was mentioning like trying to test it against libsodium. I'm applying to other libs to beat. This is absolutely insane. Like if you're beating all of these libraries. Like are you going to publish it? Like sort of let it out in the open for people to use? Or one could argue this could even be put behind a paywall, but yeah, like either one works. Have you considered what happens like after the project is done? You do all the benchmarking. As far as I'm seeing, like it's been going really well. But yeah, let's see. Um, but these libs are the default packages. They are probably not optimized for the architectures. So next step is compiling them with optimizations and doing the path compare again. I see. Wait, but I feel that's like a great feat already. Like I would be more than happy having a project and being like, oh, this just completely beats the pants out of the rest of the libraries. But yeah, this is pretty good. Yo, designed to build an crypto, I imagine, crypto lib, and write a book about cryptography for programmers with all the shenanigans you can't easily find and that nobody talks about. Yo, pretty good. So are you going to use, like, is the motivation for your Chapter 56 this crypto library? Or was it just like an experiment and then you realized, oh, I actually want to write a book and I want to write a library entirely related to cryptography? Peercoin! Oh my god, that's a perfect name! Peercoin! What? Peercoin! Oh my god. This is sort of like meeting, if there was a guy called John Math. Like, there's like this usual I don't know about you guys. I do know like among friends and etc. Right? There is this concept, this construct of like John and then something, right? When you want to sort of have a personification of a concept, right? It's like, oh, I'm really not understanding this, right? It's like, we better ask John Bitcoin, right? It's like, as if there was a person that really personified like the concept of Bitcoin, John Bitcoin. This is sort of the same. Peercoin. This is like a crazy coincidence. But yeah, I see you all still sane, so I will assume that the crypto stream is going fine. Hello, Smartest42. Yeah, hopefully I'm still sane. Peercoin. If you want to read about proof of stake, you can read my white paper. We're going to be taking a look at proof of stake later, which I imagine is like maybe you put some money on the line and then that way they guarantee you don't cheat. I'm not sure. We'll take a look at them. So my idea is reading Bitcoin white paper for sure, because it was the one that started the revolution. I've been taking a look at like other things we could read, but Bitcoin is the main one. I do want to read the Solana white paper because Solana solved a different, like, the problem of speed, right? So there's like Bitcoin solving the problem in the first place, but Bitcoin is really slow. Solana solving the problem of speed, Ethereum solving or sort of adding the feature of smart contracts and etc. and all of that. And then I am not sure if maybe we add Monero to that to solve the problem of more privacy. So we'll see. We'll see what we read. That's a lot of text. I'm not sure. Like, right, there's so many resources that we could just spend an entire month reading. Uh, at some point we have to stop. So I want to determine what that point will be. For now, I think we can just focus on what we've been looking at. But yeah, I know John video games. Bro, what are you talking? Bro, what's different, right? Them. Okay. Let's see. Well, the main motivation is to write a book about cryptography for programmers with an example library of how to do things. I see. The library could serve as a template for people wanting to get into crypto programming. This is great. Pretty good. But yeah. All right. I'm going to drink some water. Yeah. Okay. So let's see what this has prepared for us. We say we need a way for the payee to know that the previous owners did not sign any early transactions. So the problem of double spending. For our purposes, the earliest transaction is the one that counts. So we don't care about later attempts for double spend. The only way to confirm the absence of a transaction is to be aware of all transactions. In the mint-based model, the mint was aware of all transactions and decided which arrived first. To accomplish this without a trusted party, transactions must be publicly announced. And we need a system for participants to agree on a single history of the order in which they were received. The payee needs proof that at the time of each transaction, the majority of nodes agreed it was the first received. So as we're talking with Valley, this is a fundamental distributed systems problem. Many participants. How do we decide on a single order without having a single master that tells us what the order is? Right. Very interesting. So let's see. And I imagine, Valley, was this the one you were referencing? To accomplish this without a trusted party, transactions must be publicly announced, and we need a system for participants to agree on a single history of the order in which they were received. Because this is the first reference. So, I'm sure this is what you're talking about, let me know. But yeah. So we are introduced to the timestamp server. Okay, this guy seems to be very important, because he's been... No, sorry, Satoshi has been referencing this a lot. So let's see. The solution we propose begins with a timestamp server. A timestamp server works by taking a hash of a block of items to be timestamped and widely publishing the hash, such as in a newspaper or Usenet post. Okay. The solution we propose begins with a timestamp server. Timestamp server works by taking a hash of a block of items to be timestamped and widely publishing the hash, such as in a newspaper or Usenet post. The timestamp proves that the data must have existed at the time, obviously, in order to get into the hash. Each timestamp includes the previous timestamp in its hash, forming a chain, with each additional timestamp reinforcing the ones before it. Okay, this makes sense, right? Proof of work. To implement a distributed timestamp server on a peer-to-peer basis, we will need to use a proof of work system similar to Adam Back's Hashcash, rather than newspaper or Usenet posts. So the timestamp server is going to determine the order of transactions. right? By having these little block guys. And basically creating a linked list that's based on hashes. Perfect. So I guess one of the questions, well, first question I would have would be, I mean, it can not only be a chain of the hashes, right? The hashes have to hold more information than this. Yeah, because then you wouldn't be able to extract anything. You would just see a random number. So, okay, yeah, sure. So, Chapter 4, Section 4, Proof of Work. Okay, let's see. To implement a distributed timestamp server on a peer-to-peer basis, we will need to use a proof-of-work system similar to Alan Back's Hashcash rather than newspaper or Usenet posts. The proof of work involves scanning for a value that, when hashed, such as with SHA-256, the hash begins with a number of 0 bits. The average work required is exponential in the number of 0 bits required and can be verified by executing a single hash. So, pretty good, right? This is an NP problem. Okay. Can be verified by executing a single hash. Okay. For our timestamp network, we implement the proof of work by incrementing a nonce in the block until a value is found that gives the block's hash the required 0 bits. Okay. For our timestamp network, we implement the proof of work by incrementing a nonce in the block until a value is found that gives the block's hash the required 0 bits. Okay. Once the CPU effort has been expended to make it satisfy the proof of work, the block cannot be changed without redoing the work, as later blocks are changed after it. The work to change the block would include redoing all the blocks after it. This is a very smart system, right? Because, let's see, so we increment a nonce in the block until a value is found that gives the block's hash the required 0 bits. So we have the block and all of its information, and then at the end of it there would be this little guy that's just, a dumb field. It's not important or relevant for the purposes of information it can transmit. We just modify it and keep incrementing it until the hash that results from this is, has as many 0 bits as is required. So that's pretty interesting. That's pretty good. And that also gives us the side effect, or not side effect, but like side good thing, you imagine, that implies that if you change any information, so suppose you found the nonce that makes this block valid by having all those 0 bits at the beginning. Well, not valid. Valid is not the right word because the others haven't agreed. But you get what I'm saying, right? You find the nonce that has all the 0 bits at the beginning that you need. If you change any information of the block, the hash is gone. The hash just hashes to something completely different. So it means then that you would need to recompute the entire thing. So now we have a strength against people modifying blocks like however they want, right? Not only that, but Satoshi attaches the fact that since each block points to the previous one, and so on and so on and so on, then it means that you won't be able to change things so easily, right? Because then the hash, right, this block is a witness to what the hash was. If you want to change this block, then you're going to have to change the hash in the end, which means you're also going to have to change this block. And so now the amount of work is absolutely insane. So this makes sense. The proof of work also solves the problem of determining representation in majority decision making. If the majority were based on one IP address, one vote, it could be subverted by anyone able to allocate many IPs. Right, so this makes sense, right? I could just have a machine spin up, of course this is not the way IPs work or stuff like that, but I spin up 20 virtual machines, each with their IP, and then all of a sudden, right, I have a power of 20 votes instead of 1. So that's a problem. Proof of work is essentially one CPU, one vote. So there is no way to create votes artificially through software, in a sense. Right? You have to have a CPU for that to count as your vote. And, well, of course, not a physical CPU, or like, it's not a vote per CPU you have, it's just like the CPU power in general. But yeah, this seems pretty smart system. The majority decision is represented by the longest chain, which has the greatest proof of work effort invested in it. If a majority of CPU power is controlled by honest nodes, the honest chain will grow the fastest. The honest chain will grow the fastest and outpace any competing chains. Good principle, right? If the majority of the nodes are honest, well, not the majority of the nodes. If the majority of CPU power is honest, then it's highly likely that it's going to be the one that produces the longest chain. An attacker could just get lucky, right, and get the 0 bits it needs in the hash, like, in the first 3 guesses, but that's, if anything, almost impossible. So, yeah, we'll take a look at it. Give me a second. Okay. So, let's see. I'm back with Jesper. Yo, penguin operator. One of the problems with Bitcoin that later currencies like Monero tried to solve is that specialized hardware is much faster at mining Bitcoin. Not sure how successful they were. Interesting. So you're saying that, like, companies can start creating specialized hardware that is very good at mining Bitcoin. And so now CPU power is sort of like elitized. So the problem goes back to the origin. I think we know. To modify a past block, an attacker would have to redo the proof of work of the block in all blocks after it, and then catch up with and surpass the work of the honest nodes. We will show later that the probability of the slower attacker catching up diminishes exponentially as subsequent blocks are added. GPUs haven't been cheap ever since. If I remember correctly, that was the first reason why. Yeah, I remember. I was very little though. I was very little, but around like 10 years old, 11 years old. But I do remember when people were complaining, like, GPUs are all over the, all over the ceiling. Everybody's using them to mine Bitcoin. Absolutely insane. Right. It's a little bit unfortunate. Similar to, then AI came with the GPUs, but not only the GPUs, RAM. So slowly but surely we're seeing computing be more like a privilege. So, interesting. I think Monero in specific trying to make mining more memory bound, but it's not clear to me that an ASIC couldn't successfully speed up those workloads. I see. What is an ASIC? What is an ASIC? Oh, sorry. What is an ASIC in computing? Oh, application specific. Okay, that makes sense. Interesting. So we also should read Monero then, if that's the case. Like, it's interesting to see how these problems have been tackled. Who knows? Maybe we can come up with something. I don't think so, because like many smart people have taken a look at that problem, but it is fun to think about. I keep on not deleting enough when I reword things, so my sentences got mangled. That's okay. That's completely okay. But yeah, alright. To compensate for increasing hardware speed and varying interest in writing notes over time, the proof of work difficulty is determined by a moving average targeting an average number of blocks per hour. If they're generating too fast, the difficulty increases. Interesting. Okay. So there's sort of like one thing that so we've already been given the basic model of Bitcoin, right? Like we already have it in our hands. The chain of hashes is what determines everything. So my thing with this, right, my question would be, whenever you submit a block, right, that block has all of the sort of transactions inside it. Which means that, like, in the end, probably this ends up not being the case later, so let me know. Who knows? But, like, the proposer of the block would have to determine the order of the transactions that they want to put in the block, right? And so they are now a single authority that determines the order. That is fine, but what would happen if somebody proposes a block that has double spending, right? Then you would need people that are constantly verifying the blocks, right? Because, like, if it is transaction, if instead of an entire block it was a single transaction, then this would be, this would be very simple, very easy. The things as the way they are, there would need to be, not much more, but it would be really slow. So I imagine there is, like, something that's in charge of verifying that whatever people submit as a block is actually good. Like, it's valid, and it has the order of transactions, and it doesn't require, or it doesn't allow double spending in that side of that block. We'll see. Network. Alright, network. Next section. Let's see. Chains can be incrementally verified, so it doesn't slow down mining too much. Okay. So we would need somebody that just checks that the blocks that are being submitted are indeed, so that they don't have double spending. It can be very slow to independently verify if you haven't been kidnapped. I see. Network. The steps to run the network are as follows. 1. New transactions are broadcast to all nodes. 2. Each node collects new transactions into a block. 3. Each node works on finding a difficult proof of work for its block. 4. When a node finds a proof of work, it broadcasts the block to all nodes. When a node finds a it broadcasts the block to all nodes. Yes. Nodes accept the block only if all transactions in it are valid and not already spent. Oh, okay, yeah. So we introduced the verifier here. I see. Then you only need to verify the newest block. No, yes, I agree. I was saying like, oh, we're gonna need to verify the blocks. But yeah, it was just a very obvious observation. 5. Nodes accept the block only for all transactions. Oh, never mind. 6. Nodes express their acceptance of the block by working on creating the next block in the chain, using the hash of the accepted block as the previous hash. I imagine this is where the slowness comes in, right? Because this would lead... Okay. Because all of these nodes, right, they're sort of... Okay. So my thing is, a transaction hits a single node, right? And so many blocks around the world may be currently working on 5 different versions, 5 different next blocks, right? And so the moment somebody finds a proof of work, and sends it to the other nodes, first of all that compute of the other guys was lost. Not only that, but the people that have not yet received the proof of work may just continue working on it. Like the mere fact that we have racing chains, it's like only one of them can survive, which means that all of that compute that was used for the other ones is just wasted. Which I guess is necessary for the proof of work, I agree. But it's, it seems like there could be something to improve there. Because I imagine that's where the slowness comes in, right? Because you express your acceptance by assuming that this will indeed be the next block. It's very much possible that it changes in the future, and then you're like, okay, well, all the things I did are now gone. So this may be something that the other cryptocurrencies tackle to solve the problem of slowness. We'll see. Everyone races to calculate the next block since you get to award yourself Bitcoin then. Yeah. You can also charge people fees to process their transactions. Yeah, that's what right, where you have some sort of priority of sorts. Right? Because it's also the problem that, like, if say you want to buy a pizza with Bitcoin, then you would have to wait like 20 minutes until the thing is actually approved. So what do all of these exchanges actually do then? Because they make it seem as transactions were automatic. So I imagine maybe the exchange gives the other person the money sort of immediately, assuming that eventually they will get the Bitcoin that you just gave them. Right? It's the thing that makes the most sense. But yeah. Let's see. Nerds always consider the longest chain to be the correct one and will keep working on extending it. Bitcoin plans to move entirely to fees once the last Bitcoin is mined. Maybe that's already happened, though. I wouldn't know. I see. But then that sort of defeats the purpose of the abstract, right? This Kashinskin type of phrase, then we have, where is this? Oh, where was it? There was like, oh, I think it was here. The cost of mediation increases transaction costs, limiting the minimum practical transaction size and cutting off the possibility for small casual transactions. So this was one of the criticisms of the modern finance system. One of the criticisms that was created to, or sort of used to back up the whole reason of existence of Bitcoin. Right? Because Satoshi was like, oh my god, the fees in the minimal transaction, it's very bad. But if we transition to a fee-based model, then, right? Like, yeah, like what else are we supposed to, right? These creative systems would just be integrated into the system itself. Seems like to me. All right, let's see. Now, it's always considered the longest chain to be the correct one, and we'll keep working on extending it. If two nodes broadcast different versions of the next block simultaneously, some nodes may receive one or the other first. In that case, they work on the first one they received, but save the other branch in case it becomes longer. The tie will be broken when the next proof of work is found and one branch becomes longer. The nodes that were working on the other branch will then switch to the longer one. Okay, makes sense. New transaction broadcasts do not necessarily need to reach all nodes. As long as they reach many nodes, they will get into a block before long. Block broadcasts are also tolerant of abrupt messages. If a node does not receive a block, it will request it when it receives the next block, and realizes that it missed one. Okay. Yeah, everybody trying to make blockchains fast has to build some batching mechanism on top of it to avoid exorbitant gas fees and increase throughput. That makes sense. Yeah. Okay, let's take a look at incentive. Okay, because it's true, right? Right here, up until this point, there's no reason for somebody to waste the CPU power on supporting the system, right? Unless it was something like, you have to compute the proof of work for your own transactions, which first of all would be extremely slow. It would be completely inaccessible because, right, it couldn't be used casually, since, like, a single computer cannot compete against, like, the thousands of PCs present everywhere else. But yeah, let's see. Incentive. By convention, the first transaction in a block is a special transaction that starts a new coin owned by the creator of the block. Okay. This adds an incentive for nodes to support the network and provides a way to initially distribute coins into circulation, since there is no central authority to issue them. Very smart, right? This is the whole miners getting their own Bitcoin, right? Because it's over here, right? A block, a special transaction that starts a new coin owned by the creator of the block. The steady addition of a constant of amount of new... we detected a typo on the Bitcoin white paper. Wait! The steady addition of a constant amount of new coins is analogous to gold miners expending resources to add gold to circulation. In that case, there's CPU time and electricity that is expended. Fair enough. The incentive can also be funded with transaction fees. If the output value of a transaction is less than its input value, the difference is a transaction fee that is added to the incentive value of the block containing the transaction. If the output value of a transaction is less than its input value, yes, okay. Once a predetermined number of coins have entered circulation, the incentive can transition entirely to transaction fees, be completely inflation-free. What? And be completely inflation-free? How does this make sense related to transactions? Once a predetermined number of coins have entered circulation, the incentive can transition entirely to transaction fees. Oh. Wait, what? Wait, the incentive is inflation-free, right? No more coins entering circulation, yeah, but like, inflation-free would refer to the system as a whole, or the incentive? Because the way it's written, it's like the incentive can transition entirely, completely. Well, no, actually, no. I guess that makes sense. Yes. Although the transaction fees themselves, you could argue, are subject to some sort of inflation, right? Because then eventually they're gonna increase and etc. But yeah, the incentive may help encourage nodes to be honest. If a greedy attacker is able to assemble more CPU power than all the honest nodes, he would have to choose between using it to defraud people by stealing back his payments, or using it to generate new coins. Interesting. Okay. He ought to find it more profitable to play by the rules, such rules that favor him with more new coins than everyone else combined, than to undermine the system and the validity of his own wealth. Pretty good. The incentive itself is the transaction fee for the miners once no new coins are available. Yes, that's what we read. That's what I read just now. And welcome to chat, Jewel for now. Jewel for N. Yo, or Julian. That should let me know how I can read it. But yeah, Basically, you can distract greedy people with mining. Yeah. So this is pretty good, right? The incentive may help encourage nodes to stay honest. If a greedy attacker is able to assemble more CPU power than all business nodes, he would have to choose between using it to defraud people by stealing back his payments, which is also kind of interesting, right? Because it's not like, this is very interesting, right? Because it's not like an attacker could just like steal people's money, right? It cannot just arbitrarily go and say, you, Valley, are going to give to Julian or to DeFerrari this much amount of coins, right? It's gonna be different, right? It's gonna be because the attacker, as much CPU power as they have, they don't have the private key, so they can only take back money they've already given. Which, if they're not a millionaire, okay, so if they're not a millionaire, then that's not much money to gain. If they are a millionaire, why the hell are you doing this in the first place? So that's interesting. It's sort of like a, yes, it's possible, but nobody would do it kind of argument. And then, okay, you could steal back your payments, or then you could use it to generate new coins. Which is very interesting. Because then you can just, you know, put in a bunch of stuff in. We just have to trust the millionaires, easy. Alright, buddy. Maya Stutter, welcome back. Switch from the Mac? Yes, I am now on my desktop PC. Yeah, which is using Linux. But yeah. So one interesting thing I want to know, just out of curiosity, right? Whenever a new coin is created, right, which is attached as the first transaction of a block, who is the original owner? Right, because you always need to have it be, you know, attached to the public key of the previous owner and so on. Do you just leave it null? I imagine that's what you do, right? That's what you do. And there is no problem leaving it null. I'm just curious to know, like, what, you know, what it is. And yeah, so it is interesting. So the alternative, which would just be use it to generate new coins, it's just, okay, wait. Okay, I have a problem now. So I guess that question is more relevant, maybe. Where do those coins come from? Because if you can just leave the space null, you can just keep creating and creating and creating and creating coins, right? Because you could just create a block that just has like every single transaction be a transaction that comes from the void, right? The void being whatever rewards the miner after they complete a block. And then you could just approve yourself, since you have the majority of CPU power. In which case you're just generating money artificially, right? So it would be nice if the only way to generate the money was by working as an honest miner, right? Where you have like, right, where the only way to get it is with that first little transaction in the block, and then you would have to be forced to work for the system, in which case you're just a very efficient miner. But like, you would be able, if you're an attacker, to just fill an entire block with reward the miner, reward the miner, reward the miner type of transactions, in which case you just trick the system and then everything is bad. Which I guess can be tackled with a similar kind of argument, where you can just say, if somebody generates too many coins, then they generate inflation, which reduces the value of the coins they already have, and so they wouldn't do that. So, I don't know. So I guess like both alternatives have that, right? If you start defrauding people and word spreads around, trust in the Bitcoin system collapses. And all of your Bitcoins are now worth nothing. And if you take 51% control, like majority control, and then you generate a bunch of new coins, inflation kills you in the end. It seems. If you somehow manage to do it undetected. Like, interesting. Let's see. Um, the brilliant part is that since Bitcoin is so fake, if you rule it too tyrannically, people can just stop caring. I'm not saying. I don't know if people would stop caring, right? It has a very real value attached to it. But I would say that the brilliant part would be this sort of argument. Even if you were able to attack it, you're motivated to not do it. Very interesting. There's a protocol too, Bitcoin, where mining it becomes exponentially harder over time. If you don't respect the protocol, I think others will consider your chain corrupted. This is true, right? But if we are assuming a 51% miner, right, then this is not a problem because they are the majority. So they are like, oh yeah, this chain is valid. I don't care if the other 49% consider it corrupted. I just continue. But yeah, even if mining becomes exponentially harder over time, it becomes exponentially harder for the attacker, yes, but also for the other guys. So I guess it would be like the fact that the evil guy cannot generate as many coins as they thought. But yeah, well, they can stop caring about your chain at least. Yeah, but if we're assuming a 51% attack, then like impossible to just do that. But yeah, it is true, right? Plus 51%. It's not like if you control 51%, then like you're suddenly the ruler of the world. You still need to get lucky, right? Let's see. I don't think corrupt chains are considered when nodes are looking for the longest chain. Yes, I agree. But if you control the majority of the nodes, you can just tell the nodes to be like, yeah, don't worry, like this guy is legit. So yeah. So 51% attack still requires you to follow some rules. See, I don't see how. That's my thing, because you are in control of those nodes, so you can just program them the way you want, right? So you could just say, yeah, just ignore this guy. This chain is completely fine, right? The others are lying. They're saying it's corrupted. It's actually not. Just keep going. Because you have control over what the nodes do. So, yeah, I don't know. Let's see. There's a very interesting argument that to undermine the system and the validity of his own wealth. Brilliant. I guess this doesn't work in the beginning when Bitcoin was starting, where it was basically worthless with real money. Now that they have taken off, it's almost impossible. Yeah. Nodes and CPU power are a different thing. Wait. Okay. So wait, help me understand. Because like nodes are in the end pieces of software, right? If you control 51% of computing power, it means that you have access to these nodes, right? You have access to sort of this computing power. You have access to these computers. So you would just be able to make them run a modified version of the software where they just do what you want them to do. Right? Like you would still obey the Bitcoin protocol so that machines can communicate with each other and other machines can, right? But like you would just tell it like, oh yeah, if they tell you a transaction is corrupt, just ignore it, right? Because there's no one overseeing that process. There is no eye of God saying like, oh, this guy is not following the rules, right? Like the whole reason why we cannot use Paxos is precisely because we need to account for nodes that behave badly, which implies that you have in the first place the possibility to just behave badly, to have a modified version of what everybody does. A node is just a server that cares about blockchains. No matter how long your chain is, it won't be considered by a node if it doesn't pass basic validation. Yes, like this is true, right? Yes, yes, yes. Um, I agree. Okay, okay. And now to your endpoint to actually do stuff with Bitcoin, like spend it. Okay, okay. So you're saying, hmm. So you would have to have control of a majority of nodes, because then, okay, because help me understand this, because then, right, somebody, rather than having a 51% CPU attack, which would be, pretty difficult to achieve, they could just flood the system with verifiers or with nodes and then just control the nodes and reject every single transaction and then just hijack the system. In which case it may not be like as expensive maybe. It is true that nodes can't verify which transactions took place and in what order beyond trusting the longest uncorrupted chain. Okay. Okay, so my thing is the following, right? My thing is the following. The whole Bitcoin system is designed to not have a central authority that tells you what is good and what is bad, right? The way you can tell that is by taking a look at the longest chain. That's the first premise. The second premise is if you're an attacker with 51% CPU, you generate the longest chain. And therefore all the nodes are forced to trust you. If we are somehow able to create the system so that you can arbitrarily just say, yeah, don't believe this guy, he's corrupted, it would be defeating the entire purpose, right? Because then it would just mean that like people can just do whatever they want. And say like, oh yeah, the longest chain, yeah, I don't care about the longest chain. I prefer this other guy. Would that defeat the purpose of Bitcoin then? Like, but they can verify the Bitcoin is minted according to the protocol. Okay, I see what you're saying. So you're saying that what I mentioned about a block full of minor transactions, like reward the miner, reward the miner, reward the miner, reward the miner, would be rejected. It would be said like, yes, this is a long chain, but it's invalid. Okay, yeah, I feel that would make, yeah, that makes sense, that makes sense. Yeah, maybe what I'm saying is just stupid. Yeah, yeah, okay. In that case, you still play by the principles of Bitcoin, still are able to stop those things from happening. Then this is brilliant, right? Because any attacker is just a really efficient miner. It's just kind of funny, but yeah, um, it's like the system heals itself. It's, any attacker has to work for the system. Pretty good. Pretty good. Okay. All right, let's continue. Section 7, reclaiming disk space. Once the latest transaction in a coin is buried under enough blocks, the spent transactions before it can be discarded to save disk space. To facilitate this without breaking the block's hash, transactions are hashed in a Merkle tree. Yo, let's go. Yeah, 51% attacks have the work of solo things than stealing all the Bitcoin. Yeah, for sure. For sure. Yeah. Okay. To facilitate this without breaking the block's hash, transactions are hashed in a Merkle tree with only the root included in the block's hash. All the blocks can then be compacted by stubbing off branches of the tree. The interior hashes do not need to be stored. Okay, so transactions are hashed in a Merkle tree. Oh, so we just added a new element to our block. This is like a different design of. Okay, so this is the block that you propose to people, right? And then I imagine if you say like, oh yeah, this guy, this block is very old. This block we sort of know by this point in time. There's so many blocks after it that like we just know it's gonna stay there. Okay. How to compact it? So we just have all of the transactions in the block, right? All of the transactions in the block, and we create a Merkle tree of those transactions, and we compact the block by just including the root hash. Okay. All blocks can then be compacted by stubbing off branches of. So interesting. Why are we only stubbing off branches of the tree and not just including only the root hash? Because I feel like that would be more than enough, right? If you just put in the block the root hash. I imagine then that there's gonna be nodes that are specialized in like keeping the entire record, so that you're able to verify somebody's log, right? Because if you're only able to see the root hash, it means that you don't know what these transactions were. So there has to be some guy that keeps track of what those transactions were, and then you're able to request them, recompute the Merkle tree, and that's it. Verify. Because the root hash doesn't tell you what transactions took place. Yes, but like neither do hash 01, right? Like hash 01 is just like a guy. It just doesn't, right? Like hash 2, the same thing. So if you're able to prune branches off of a block's some transactions, then you can just like just store the root hash, ask for the transactions later from some other guy, use these transactions to verify that the root was computed correctly, and then that's it, right? Let's see. Avitranis, everything okay with the earthquake in your hometown? Yes, thankfully. My family is okay. It was very scary, but thankfully all my family members are okay. Thank you for asking. But yeah, to those who don't know, Colombia had an earthquake very recently. It was very devastating, but thankfully all of my family as well. But yeah. You store the root hash always and compact the branches when the transactions have already been superseded by other transactions with move the money further. Oh, okay. If A sends money to B and then B sends money to C, you can delete the AB transaction. Yes, like, right, this is the whole reason why we can prune. I see, so the only reason why you would keep the transactions that represent sort of the last point this coin was seen in. Or like, maybe not the last point, this transaction is like 10 transactions away from like the last point we saw the coin. So like at this point in time, we can just prune it. In which case you eventually, as time goes on, you can just store the root hash, right? Like for very old blocks, I imagine. So you keep just enough transactions to reconstruct the current state of coin ownership. Okay, yeah, makes sense. A block header with no transactions would be about 80 bytes. Okay. If we suppose blocks are generated every 10 minutes, then 80 bytes times 6 times 24 times 365 is 4.2 megabytes per year. With computer systems typically selling with 2 gigabytes of RAM as of 2008. Wait, this is a very interesting sort of piece of the past. Right? With computer systems typically selling with 2 gigabytes of RAM. Like, this was 2008, right? In 2008, like, software was pretty advanced, right? Some of the software that we have right now is present in 2008. At what point in time did we require the minimum of RAM to be between 8 and 16 gigabytes? That seems so absurd to me. Like, when I was a kid, having an 8, like, and that's not long ago, having an 8 gigabyte, like, 8 gigabyte computer was like, damn, right? And for some of you that are like older than me, I imagine how, like, right? I imagine like back then, if you say 8 gigabytes of RAM, you'd be like, damn, like this guy's rich, or like he's probably doing some very complex stuff in their computer. But no, now you need like, wait, what's the minimum around? Okay, minimum RAM to run Windows 11. Okay, 4 gigs. 4 gigs. Oh, we'll feel very slow. Okay, 8 gigs is the practical minimum. Where? At what point in time is 8 gigs the practical minimum? For basic tasks like web browsing and office work. In 2008, you required 2 gigs for that. Even less, because 2 gigs was sort of a standard. That would mean that you would be able to run in like maybe 1 gig of RAM, right? A little, you know, a little bit on the line, but still you would be able to. This is insane, right? I don't think Windows can handle just 8 gigs too well. It starts to choke on all the memory. Yeah, I mean, this is insane. I don't know. Let's see. You keep just enough transaction. Yeah. Bitcoin people aren't too enthusiastic about keeping receipts. Hello, Andrew. Yay. My 2013 MacBook Pro came with only 4 gigs of RAM. I upgraded it to 16 gigs when RAM was still cheap. Damn. Look! They have RAM! Everybody, jump them right now! They have RAM. Yeah, bloatware everywhere. Yeah, I agree, Jewel. Yeah, okay. Let's blast off the past with this little phrase. Typically sung with 2 gigs of RAM as of 2008. In Moore's law predicting current growth of 1.2 gigabytes per year, storage should not be a problem even if the block headers must be kept in memory. Yeah, this guy did not really hold 1.2 gigs increase per year, but that's okay. I mean, it's relatively close. Storage should not be a problem even if the block headers must be kept in memory. Yeah, you know, 4.2 megabytes per year, that's like almost nothing. Pretty good. So we have number 8, simplified payment verification. It is possible to verify payments without running a full network node. A user only needs to keep a copy of the block headers of the longest proof of work chain, which she can get by querying network nodes until he's convinced that he has the longest chain, and obtaining the Merkle branch linking the transaction to the block it's timestamped in. He can't check the transaction for himself, but by linking it to a place in the chain, he can see that a network node has accepted it, and blocks added after it further confirm the network has accepted it. As such, the verification is reliable as long as honest nodes control the network, but is more vulnerable if the network is overpowered by an attacker. While network nodes can verify transactions for themselves, the simplified method can be fooled by an attacker's fabricated transactions for as long as the attacker can continue to overpower the network. One strategy to protect against this would be to accept alerts from network nodes when they detect an invalid block. protect against this would be to accept alerts from network nodes. So this is similar to what Valley mentioned. Prompting the user software to download the full block and alert transactions to confirm the inconsistency. Businesses that receive frequent payments will probably still want to run their own nodes for more independent security and quicker verification. And I think we're reaching the end. Yeah, this is the last page. Okay. Makes sense. Combining the split in value. Although it would be possible to handle coins individually, it would be unwieldy to make a separate transaction for every cent in a transfer. To allow value to be split and combined, transactions contain multiple inputs and outputs. Normally, it will be either a single input from a larger previous transaction, or multiple inputs combined in smaller amounts, and at most 2 outputs, one for the payment and one returning the change, if any, back to the sender. Let's see. Are you reading it for 1.5 hours? It is important to read every word by word. True. I mean, I assume so. The thing Andrew is that like the paper is only 6 pages long, so we're basically going to end now. Because the other ones are like calculations. We are going to read the calculations, but you can see like a good chunk of it is just taken by the equation and the code. So yeah, and these results. So the paper basically ends in page 6. 6.5 actually. Let's see. It should be noted that fan-out, where a transaction depends on several transactions, and those transactions depend on many more, is not a problem here. A transaction depends on several transactions, and those transactions depend on many more, is not a problem here. There is never the need to extract a complete standalone copy of a transaction's history. What? It should be noted that fan-out, where a transaction depends on several transactions and those transactions depend on many more, is not a problem here. Wait, but this actually... Okay, it's not a problem here, as in like, this is not a problem, but it... Because I think that is what's taking place, right? If you have multiple inputs, you're going to depend on each of them, and then they're going to depend on a bunch of them, and so on and so on and so on, so the tree expands exponentially. Is it saying no, that doesn't happen, which I think it's false? I think it's just saying that's not a problem, and then they just say there is never the need to extract a complete standalone copy of a transaction's history. What? I mean, I guess so. I guess so. It is helpful to like, you know, like blockchain investigators to catch bad guys, but yeah. I guess so, right? Privacy. Let's see. The traditional banking model achieves a level of privacy by limiting access to information to the parties involved in the trusted third party. The necessity to announce all transactions publicly precludes this method, but privacy can still be maintained by breaking the flow of information in another place, by keeping public keys anonymous. The public can see that someone is sending an amount to someone else, but without information linking the transaction to anyone, right? There is no way to recover where or who is the person behind this. Okay. This is similar to the level of information released by stock exchanges, where the time and size of individual trades, the tape, is made public, but without telling who the parties were. Pretty good. As an additional firewall, a new key pair should be used for each transaction to keep them from being linked to a common owner. Some linking is still unavoidable with multi-input transactions, which necessarily reveal that their inputs were owned by the same owner. The risk is that if the owner of a key is revealed, linking could reveal all the transactions that belonged to the same owner. Let's see. I think the idea is that the legitimacy of a transaction never depends on where the money comes, since legitimacy is determined on a per-chain basis. There's no concept of money laundering within a single chain. Okay, makes sense. So, well, there's something I need to understand now then. When we say, so you need to generate, or like one of the things that's being said here, right? It's a new key pair should be used for each transaction to keep them from being linked to a common owner. Let's see. Great stream, gotta go now. Classes start today for me. Yo, let's go. Good, Jewel. Let's go. Time to learn some discrete math and all the shenanigans. Yay. Perfect. Good luck with the classes. That says either you trust the chain and all potential sources of the money legitimately owned it, or you don't and the transaction is void. Okay. Makes sense. But I still have a question with this, right? A new key pair should be used for each transaction to keep them from being linked to a common owner. So, sort of, your account, right? Your Bitcoin account, your Bitcoin wallet is linked to a given pair of keys, right? To a given private key and to a given public key. Because the public key is included in the transaction chain so that other people can verify, and your private key is used to sign transactions. And so people still need that private key to be the same for the public key to be able to verify what you signed. And the public key still needs to be there because, right, it's the one that's sort of the witness of these coins belong to this little guy, right? So like coins are attached to the key pair that you have. Suggesting that a new key pair should be used for each transaction to keep them from being linked to a common owner, does it just mean creating a new account, which would just be, you know, another set of keys, transfer the money to that, or like transfer a given sort of transaction to that, and then transfer it to someone else? But I feel like, you know, people would very quickly just clock it immediately and say like, yeah, this guy transferred the money to this other guy, and then this other guy always transfers it to the same place. Like, I guess that is what blockchain like investigators do, and they're like always going around and being like, the money was transferred here, and then it was here, and then it was here, and so on and so on and so on. But yeah. Not legally speaking, of course. Yeah. Your comment, of course, is not gonna be like, oh, the transaction is void, so the whole Bitcoin system has to agree with me. But yeah, I think the result of each transaction is basically a whole account. What do you mean? Because like your public key is attached to the transactions you receive. So like all those coins can, like you can only use those coins and transfer them to someone else. Like you can only use the coins you own and transfer them to someone else if you use the same private key that is coupled with the public key that was attached to the transaction originally, right? Because here in the original guy, in the diagram that we were like looking at, here, right? It's like if owner 0 wants to transfer to owner 1, they attach the owner 1's public key, then the hash, and then they sign it. Which means that whoever wants to verify that this indeed belongs to owner 1 needs to have their public key, right? And so owner 1 should have to sign the next transaction they do with the same private key that they used for the public key that was present in the transaction that arrived. so that this public key can verify whatever they sign. And so your private key and public key are basically your account, because otherwise you cannot move the money, right? So it seems like that's the case. Correct me if I'm wrong. So then what Satoshi suggests of like moving the money somewhere else, like using a different pair, is like, how would you do this? Would you just every time just create a new account, transfer the money to the new account, then perform the transaction and forget about that account, then create a new account, transfer the money to that account, and then but then it would be sort of useless because people can just see, oh, this guy transferred it to this guy and then it transferred it to this guy. So given that this guy just transfers to a bunch of random accounts, it's probable that they're just trying to do it. And so I'll just ignore the middle node and connect the dots. So I'm not sure what Satoshi was talking about when they said this. Right. Create a new key pair. Common owner. So that's the thing I'm confused about. Some linking is still unavoidable with multi-input transactions, which necessarily reveal that their inputs were owned by the same owner. The risk is that if the owner of a key is revealed, linking could reveal all the transactions that belonged to the same owner. I guess this is what, like, I don't really know. I don't think there's really a concept of accounts per se. Rather, you match outputs of previous transactions. Yes, that like this. This is what I mentioned, right? That's why I always do like account, right? Because like technically it's not an account. But like your public key and your private key are what identify you. And like those coins belong to that specific pair of public and private key because of what we mentioned before. So like public and private key you can think of as an account, right? Like you can only move the money around if you have access to these. And it's not like you can just change them, because all the coins are just linked to them, right? Linked as in like the blockchain is pointing at your public key as the owner of that coin. And so like virtually it's like, I'm not understanding why they say like, oh, a new key pair should be used for each transaction. Because it's not like you could just change it. Because then people wouldn't be able to verify the chain of ownership. Right, because you still need to use the same private key and the same public key to sign the next transaction and to do whatever, right? For example, you can spend some money under one private key and claim the change under a new private key. Okay. So basically you're just creating a different account in a sense and then just transferring the money to it. In which case you could still link it, right? Because you're like, okay, I'm gonna pay for this service, and then, you know, the change is gonna go to this other account. Like, anyone seeing this, it's like, yeah, this guy owns both accounts. Like, there's no reason why they would transfer the change not to themselves, right? The second alpha for change seems to be to avoid having mutable accounts. I see. But like, right? You could still link them together and be like, yeah, like this guy is just the same guy. So I guess that's what Satoshi is saying here. Linking could reveal other transactions that belong to the same owner. In which case, I don't see the effectiveness of having a new key pair. It just makes it so that lazy people are not able to link them together, but like anybody could just link them, right? I guess maybe that's what the concept of like, I have no idea about cryptocurrency, so please forgive me if I'm saying something completely wrong. Where like tornado, is tornado the name? Tornadoes go in? I don't know how a tornado works, like a cryptocurrency tornado works, but I imagine it's like somebody or like some sort of thing that shuffles a bunch of the money around and then just outputs it to some other random account. And then it's like, yeah, very difficult to follow around. But if you have enough dedication, you could. I imagine, right? A mixer, yes, 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 yes. I think it's because like there was a mixer called Tornado X or something like that. Bitcoin, Tornado Cash, probably. No, no, no. Something like that. But yeah, yeah, a mixer, a mixer. All right, all right. Wait, this was a pretty interesting read. I feel it wasn't that bad to understand. I feel we understood pretty good the concept. God of Penguin. Hi. Welcome to the chat. Welcome to the chat. We just finished reading sort of the main nitty gritty of the Bitcoin wallpaper. Now we're gonna take a look at the calculations, but like the paper is already its contents are there, which is great. It says here the following. Give me 1 second. Okay, let me see my calendar. Okay, perfect. Calculations. We consider the scenario of an attacker trying to generate an alternate chain faster than the honest chain, right? Let's see, these could be less obvious cases. For instance, you could treat the change output and the normal output interchangeably. I guess so. Yeah, I mean, yeah, you could just like try and make it less obvious. But like somebody with enough dedication can just go around and like tie in all the threads. I guess the more effort that it implies, the better. God of Ping, can I ask you a question? Yes. Sure. I don't know. That like depends on what the question is. But yeah, you can ask the question. Whether I answer, depends. But yeah. I'm trying to make a web scraper that could scrape deadline clubs, activities, opportunities available. Okay. I'm going to refill the water. I'll be back in a second while God of Ping writes a message. Delicious water. Alright. Let's go. Okay. Opportunities available. Should I train an AI from scratch or use an API? What do you mean by use an API? Does the site have an API? I imagine no, because you're web scraping. What's the actual website? Yeah. It would generally be from my college website and nearby opportunities available at kilometers radius. Delicious American chlorine water, yeah. Cheers. Okay, nearby opportunities. Okay, I see. But I don't understand what you mean by use an API. Do you mean like use a third-party service that already has like a web scraper? There's multiple websites? Not sure. Okay, I'm gonna start reading this section, elaborate a little bit on what you mean. You could, as a Gemini API and prompt engineering. Oh, you mean using an API for a given AI? Okay, I see. I think I am very much the wrong person to ask this question to, because I don't have much experience with like all of the AI, chatbots and like whether training something from scratch is better than using the API. Cost I see as an issue, yes. There's also like, I mean, from the perspective of somebody that has absolutely no idea of AI. Um, there are also like all of the open source models, in which case you just need to have a very powerful machine and pay your electricity, but maybe it's worth it in the long run. If your university has a computing cluster, which usually some universities do, and you for some reason have access to it, could try it out. Trying to call Chelpa, which will post opportunities, deadline first, activities. Yeah. No, I definitely see the project idea. Um, One important thing would be, maybe this is like perhaps a little bit naive, but would you need an AI for this? Is my question. Because web scraping is like way older than AI, right? And before the AI era, you had a bunch of web scraping services that worked really well. So the detection of deadlines on a website, right, could be performed well with some heuristics maybe. If cost is an issue, you could just create like good heuristics to extract them. But yeah, like it could be student reported. So what do you mean? Like a comment on Instagram that just says this thing is gonna happen, right? AI isn't really necessary, but it does seem. I agree, it does seem well suited. But like, if cost is an issue, like maybe you can try to go like the traditional web scraping way. Because I agree, right? If you have access to AI, it would be perfect, because it's better than any web scraping you can make. Because it's able to extract things from actual context, right? It's not just the syntax; it understands semantically what's going on. But if cost is an issue, yeah, you would have to compare the rates, because training a model from scratch, like, I have no experience with training models, so I really cannot tell you. But that seems like, I'm not sure how good of a job it would do. Maybe you could consider just an open weight model and just use it, right? I can't imagine you'd need to pull individual web pages that much. Maybe once every few hours per page. That is true. That is a good argument, right? Like, the AI fees are not going to consume you, because you can just feed it the website that may have the information. AI could launch multiple agents for each web page. Yeah. But like, you could consider this like a practical bound on the cost for each website, which is not going to be that much unless your website is like ginormous, right? And then every hour, you can just feed it again to the AI. The AI will just try and find and then output, and that's it, right? If you have, say, I don't know, 12 websites, right? And you feed them to the AI each hour, like, I feel like what Valley is saying is pretty good, right? What good would that do? It seems like one AI per page would be up to the task. I agree. I think like multiple sub-agents wouldn't really make much sense, unless once again the web page is extremely huge and then your context windows get completely bloated. But I don't think the cost per website would be huge. I think it could be actually very cheap. Say you have 12 websites once again. Yeah, if you have 12 websites, every hour you feed those 12 websites, like each website to one AI, right? And that's it. Right? I don't think they're gonna charge you much for a single AI processing one website. It's gonna be cents, and then that's it, right? So like, major idea is there would be a chatbot. Let's say you ask it, I'm a CS undergrad, what assignment are due in week or any club hackathons? Lang graph. What? since the task is basically simple for any capable of basically, I think you'll be fine. You'll be fine. You can just grab a couple of websites where you know the information is going to be and feed it each to an AI. Let it write the summary. Let it tell you what the deadlines are through a specific given format, maybe just Pydantic or something, and that's it, right? LangGraphs is a frame which allows multiple agents to coordinate. I agree. What I'm saying is I don't think there is a need for multiple agents. Once again, completely ignorant in masses of AI, right? No AI is written in the title, so it gives you kind of an opinion of what I think about it. But I don't think you would need many sub-agents, right? Because like it's a very simple task, right? First of all, you do the parsing, and the parsing for the website. You just have one AI parse that one website, extract the information, and store it in a database somewhere. When somebody asks the question in the chatbot, the AI is not going to go and scrape again, and it's just going to query that database, see what data is there. Since the data is already compressed, it's already exactly what you need. It's going to be, if anything, like 1 page long. If there's many deadlines, right, it's going to be like 1 page long. And then an AI can just read that condensed information that the parsers already had and simply say, oh yeah, your assignment is due this time. And, you know, the hackathon starts in May. So yeah, I don't think you need multiple sub-agents, right? You just need to separate the chat from the parsing and scraping. Because if you spawn agents every time a chat message comes by, that would be really, really bad. I'm currently working on prototype V1, no web scraping, just doing reported in like different section for each branch. Yeah, then in that case, it's like even easier, right? Because then you just need a single AI. You could have a list of web pages for your monitoring. Yes, every few hours sends out API calls to read them and generate summaries, which you store. Then when someone asks a question, it looks at the lists of some of most recent summaries and produces a result. Exactly. That exact same thing that Vali is saying is what you would need to do, right? Separate the scraping from the actual analysis and you'll be fine, right? Like you condense the information first, then you can just have a single AI look at all the information you've collected, which is going to be very little, since across a huge website that's going to be like 2 deadlines, each of which just comprises like 80 characters. And so then you can just feed all of that to the AI, and then it's going to be able to look for it, blah, 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 and that's it. So yeah, every few hours, just allow the parsers and the scrapers to take a look at where the information is. And every single time a chat message comes, just make that chatbot look at the database. But yeah. Urchiox, welcome to the chat. Let's see. How many years do you have with Rust, man? Can you guess? Can you guess? Yeah. Well, you know. I have 0 years. Yeah, these streams are also being used to learn Rust. I'm learning Rust. God of Ping says, that could work. You wanna who's in my team? What do you mean? That could work. You wanna who's in my team? Wait, sir, what do you mean? Are you saying that you're gonna communicate this to the people in your team? If so, that'd be great. But, oh, do you want to know who's in my team? I see. Code is primary dev, plot code is secondary dev. Okay. You might want the scripper AIs to read the previous summary as well as the web page and the synthesis. Yeah, so it doesn't forget things too easily. Yeah. Urchiox. Okay, I too. Fine. Now I'm dev JavaScript, bro. Yo, let's go. Perfect. All right. I'm gonna finish reading this section, and then we can transition to learning Rust. So we have 11 calculations. We consider the scenario of an attacker trying to generate an alternate chain faster than the honest chain. Even if this is accomplished, it does not throw the system open to arbitrary changes, such as creating value out of thin air or taking money that never belonged to the attacker. Nodes are not going to accept an invalid transaction as payment, and honest nodes will never accept a block containing them. An attacker can only try to change one of his own transactions to take back money he recently spent. The race between the honest chain and an attacker chain can be characterized as a binomial random walk. Let's go. This is the interesting part. The success event is the honest chain being extended by one block, increasing its lead by +1. And the failure event is the attacker's chain being extended by one block, reducing the gap by -1. Yes. The probability of an attacker catching up from a given deficit is analogous to a gambler's ruin problem. Yo, let's go stochastic processes once again. Yay. Suppose a gambler with unlimited credit starts at a deficit and plays potentially an infinite number of trials to try to reach break even. Okay. We can calculate the probability he ever reaches break even, or that an attacker ever catches up with the honest chain, as follows. P, probability that an honest node finds the next block. Q, probability the attacker finds the next block. And QZ is the probability that the attacker will ever catch up from Z blocks behind. So we see that this is the usual formula for a random walk. It's a stochastic process. Pretty good. Given our assumption that P is greater than Q, the probability drops exponentially as the number of blocks the attacker has to catch up with increases. With the odds against him, if he doesn't make a lucky lunge forward early on, his chances become vanishingly small as he falls further behind. We now consider how long the recipient of a new transaction needs to wait before being sufficiently certain the sender can't change the transaction. We assume the sender is an attacker who wants to make the recipient believe he paid him for a while, okay? Then switch it to pay back to himself after some time has passed. The receiver will be alerted when that happens, but the sender hopes it will be too late. The receiver generates a new key pair and gives the public key to the sender shortly before signing. This prevents the sender from preparing a chain of blocks ahead of time by working on it continuously until he's lucky enough to get far enough ahead and executing the transaction at that moment. Interesting. The receiver generates a new key pair and gives the public key to the sender shortly before signing. So this is an interesting application of spawn a new account immediately before that happens. Okay, that is very interesting. Okay, once the transaction is sent, the dishonest sender starts working in secret on a parallel chain containing an alternate version of this transaction. The recipient waits until the transaction has been added to a block and Z blocks have been linked after it. So he's gonna hold the guy and say, you don't leave my store until Z blocks have been appended to the thing you just gave me. Great. He doesn't know the exact amount of progress the attacker has made, but assuming the honest blocks took the average expected time per block, the attacker's potential progress will be a Poisson distribution with expected value Z of Q over P. Makes sense. To get the probability the attacker could still catch up now, we multiply the Poisson density through each amount of progress he could have made by the probability he could catch up from that point. Okay, this is the usual Poisson formula. Rearranging to avoid summing the infinite tail of the distribution, we get this. What are we doing here? Okay, converting to C code, we get this much. And then, running some results, we can see the probability drop off exponentially with Z. Okay, so we have Z, the amount of blocks after which the attacker would be able to catch up, right? So of course, if it is 0, then, you know, you have probability 1 of succeeding. Q being, if I remember correctly, was like the probability the attacker finds the next block. So the probability that the attacker finds the next block being 10%, with a single block, with no blocks in front, then could just be there, right? Z equals 1, it would be a 20% chance, 5%, 1%, 0.3%. And so after 10 blocks, we just have it like completely vanished. Pretty good. At Z equals 0, isn't it invalid? Oh wait, let me read the rest of the chat. I just know the intermediate Python and basic Django trying to accomplish this. At Z equals 0, isn't it invalid? What do you mean invalid? It just means that, like, you know, the transaction was just generated. The function. You mean our Poisson distribution guy? I don't see why that would be the case. K factorial. What do you mean? K factorial. I think this is fine now. Because if your Z is 0, then K equals 0, Z is 0, so there's only going to be one instance of the sum. This lambda is going to be 0, and then 1 minus 0 is just 1. So the probability of catching up would indeed be 1. Because there's just nothing in front of it, so. Actually, I'm trying to. I think the formula is completely valid at Z equals 0. What I would rather question is this guy. I guess the probability that the attacker could ever catch up, right? I don't see why this would be 1. Maybe there's something I'm misunderstanding. Let's take a look at this again. What is going on? So, given our assumption that P is greater than Q, the probability drops exponentially as the number of blocks the attacker has to catch up with increases. With the odds against him, if he doesn't make a lucky lunge forward early on, his chances become vanishingly small as he falls further behind. And Z is the amount of blocks of advantage that we have as the honest people, right? It's valid, yeah. So Z is, probability the attacker will have control from Z blocks we have. So Z is the amount of blocks we have as an advantage. The receiver generates a new key pair and gives the public key to the sender shortly before that. This prevents the sender from preparing a chain. Yes. Once the transaction is sent, the dishonest sender starts working in secret on a parallel chain containing an alternate version of his transaction. The recipient waits until the transaction has been added to a block and Z blocks have been linked after it. He doesn't know the exact amount of progress the attacker has made, but assuming the honest blocks took the average expected time per block, the attacker's potential progress will be a Poisson distribution with expected value this much. Okay. It will be, this is usual formula for lambda. To get the probability that the attacker could still catch up now, we multiply the Poisson density for each amount of progress he could have made by the probability he could catch up from that point. Which makes sense, right? So suppose Z is 10. We say, okay, multiply, it's sort of like, right, like expected value is the way I would describe it. Could have made by the probability he could catch up from that point. Yeah, so if I am 10, like at this point in time, right, the attacker, I don't know, say we're 10 blocks of advantage, then it would be the possibility they have completed 10 blocks, what's the probability they catch up? The possibility they have completed 9 blocks, what's the probability they catch up? 8 blocks, what's the possibility, and so on, and then we add them together, right? Which makes sense. So if the amount of blocks you have sort of produced as the attacker is more or equal to the amount of blocks I have as an advantage, then this is going to be the probability you catch up to me. Yes. And then if k is greater than z, that is, you already surpassed me, then it's going to be 1. Rearranging to avoid summing the infinite tail of the distribution. So this is just... Okay, yes, we rearrange. This is equivalent to that. And so now the question is, if z is equal to 0, right, what happens? Because k is equal to z, I guess it means, right, catching up means they are at the same level as me, rather than they have an advantage over me, in which case it would be 1 at k equals 0. Okay, q is equal to 0.1, right? Then z is equal to 0, and that means he already caught up to us. Z is equal to 1 would lead a probability of 20%. 20% that they catch up. Question is why? Like intuitively, right? Intuitively. Because if you were to ask this to me naively, I would say 10%, right? I only have 1 block of advantage. I would even say less than 10%, but I'll have 1 block of advantage. The probability that they generate the next block is 0.1, right? In which case, they would just be able to, you know, they have a 10% chance of generating the next block, and thus taking us to the z equals 0 case. Why is it 20%? Like intuitively. I know I might be seeming like very stupid here. I don't care, right? I want to understand why this is the way it's behaving. Jocks, what is the behavior of the graphics? That is a good question. We can take a look at the charts maybe later, but I do want to understand this sort of fundamental part. Theodore 0110, so probably like Theodore 6, maybe. Okay, Theodore 6. Hey, how are you, man? I'm good, thank you. How about you? Yeah, I hope you're doing well. Currently, I'm trying to understand these probabilities that Satoshi listed here, because they also don't... What? Yeah, what's going on? Why? Okay, we're gonna have to make a review of Poisson distribution. I'm sorry, people, but we're gonna have to calculate the probability he ever reaches break-even or that an attacker ever catches up with on this chain. Okay. The probability that the attacker will ever catch up from z blocks behind. This. So this is... Okay, this is what I'm thinking of. Right? So I am misunderstanding this entire section. Let's see. Let's read this again slowly. Given our assumption that p is greater than q, the probability drops exponentially as the number of blocks the attacker has to catch up with increases. With the odds against him, if he doesn't make a lucky launch forward early on, his chances becoming vanishingly small as he falls further behind. We now consider how long the recipient of a new transaction needs to wait before being sufficiently certain the sender can't change the transaction. We now consider how long the recipient of a new transaction needs to wait before being sufficiently certain the sender can't change the transaction. We assume the sender is an attacker who wants to make the recipient believe he paid him for a while, then switch it to pay back to himself after some time has passed. The receiver will be alerted when that happens, but the sender hopes it will be too late. The receiver generates a new key pair and gives the public key to the sender shortly before signing. This prevents the sender from preparing a chain of blocks ahead of time by working on it continuously until he is lucky enough to get far enough ahead, then executing the transaction at that moment. Once the transaction is sent, the dishonest sender starts working its secret on a parallel chain containing multi-relation transaction. Important. We're able to prevent the attacker from working before they transfer us the money. Once they transfer us the money, we cannot sort of stop them and say like, no, don't work on your alternate chain, right? Seems like it. So, good. We're not able to stop that guy. Great. The recipient waits until the transaction has been added to a block and Z blocks have been linked after it. So, it's not like we have an advantage, right? It's not like we have an advantage. We just start the race, both of us at the same time, and then we have to, blocks are being added, blocks are being and so on. So it's like a race between two chains. The seller, the recipient, doesn't know the exact amount of progress the attacker has made. So say I tell you, oh, Z blocks, like 3 blocks have been linked to the transaction, right? Then it becomes a problem of, well, I don't know if the attacker has computed those 3 blocks and then they can just, in the next few minutes, overtake me, right? And then all of a sudden the chain is different. I don't know. I don't know what progress they've made. But assuming the honest blocks took the average expected time per block, the attacker's potential progress will be a Poisson distribution with this expected value. The attacker's potential progress will be a Poisson distribution with expected value lambda. So at any point in time, they could boom, 1 progress, boom, 1 progress, boom, 1 progress, right? The expected value of that distribution would be this guy. So this is the rate factor of a Poisson distribution, right? Rate factor of Poisson distribution. Yes, lambda. Represent the average or expected number of times a random event happens in a fixed unit of time. Lambda 3, okay, an average of lambda 3 calls per minute at all times of day. Calls the net probably about. Okay. Yes, so we have the probability mass function being this guy. Said to have a Poisson distribution with parameter greater than 0, given by this guy, where k is the number of occurrences. E is Euler's number, k factorial to factorial, to the expected value of x and also to its variance. Okay. So x is the number of events that have taken place. The probability that the number of events that have occurred is the same amount that you gave me is this much. Okay. Okay. Perfect. So here we have the expected value, which would be lambda, of who? The attacker's potential progress. Okay, this kind of makes sense. No, this makes sense, right? The more blocks that are produced, the more time the attacker has had to make progress. Good. And okay, intuitively makes sense. And of course, this formula just follows the usual one. To get the probability the attacker could still catch up now. So remember, we are on a race. And we say, well, the attacker has not overcome us yet, right? Say it's been 10 blocks attached. Then we say, well, the attacker has not yet beat us. How confident are we that the attacker is ever going to catch up in the first place? So to get the probability the attacker could still catch up now, we multiply the Poisson density for each amount of progress he could have made by the probability he could catch up from that point. Pretty good, right? This one makes sense. If the amount of progress you've made is k, then this is the probability you catch up. Okay? Pretty good, I would say. Rearranging to avoid summing the infinite tail of the distribution, then we rearrange. Okay, this formula makes sense. It still doesn't answer, at least for me, this sort of question of like at z equals 0. Actually, no, yeah, they have caught on already if z equals 0. If z equals 1, okay, and then, okay, perfect. We understand completely the formula, that's great. And so we see that at z equals 10, if the probability is 10%, then we know that if we wait 10 blocks, then we're gonna be so fine, right? Perfect. All right, great. So if we have this, and then we try and solve for p less than 0.1%, for a Q of 0.10, you would only need to wait for 5 blocks. For a Q of, say, 20, right, or 20%, okay, you would only need to wait for 11. Good, good. How many Bitcoin blocks are produced or mined, right? Produced per hour. 6 blocks per hour. Oh my god, that's extremely slow. How many transactions does a single Bitcoin block have? Okay, 2,000 to 5,000 transactions with a recent average, okay, 5,000, around 5,000. Okay, so never mind. Okay, it's, you know, decent. Still, right? You need to wait like basically what, 50 minutes just to have yeah, I see. Okay, but that's, you know, that's still pretty fine. It's a good argument to say this is a way in which you can prevent fraud, and this is a way in which CPU power allows you to overtake people. Good. Conclusion. We have proposed a system for electronic transactions without relying on trust. We started with the usual framework of coins made from digital signatures, which provides strong control of ownership, but is incomplete without a way to prevent double spending. To solve this, we proposed a peer-to-peer network using proof of work to record a public history of transactions that quickly becomes computationally impractical for an attacker to change if honest nodes control a majority of CPU power. The network is robust in its unstructured simplicity. Nodes work all at once with little coordination. They do not need to be identified, since messages are not routed to any particular place and only need to be delivered on a best effort basis. Nodes can leave and rejoin the network at will, accepting the proof of work chain as proof of what happened while they were gone. They vote with the CPU power, expressing their acceptance of valid blocks by working on extending them and rejecting invalid blocks by refusing to work on them. Any needed rules and incentives can be enforced with this consensus mechanism. Mm. References. We finished! We finished! Yo, Bitcoin white paper. This is pretty good. Pretty good. Let me read the chat now. Okay. You could, but I would just store as JSON would be... Oh, referring to the database? Yeah. You should look into the E language after this. It's an interesting piece of cryptocurrency / smart contracts history. I'm not the biggest fan of cryptocurrencies, but Nick Szabo, the guy who invented smart contracts, is pretty cool. I like his blog. Nick Szabo. American computer scientist and legal scholar. This is pretty good. Smart contracts in 1994? What? I did not know smart contracts were a thing before Bitcoin and everything. Wow. I also don't know much about what a smart contract is or how it works, so. Wow. Wow. Bit gold, yeah. Yes, in Zhao's visual structure. Dedicate computer power to solving cryptographic problems. In a Bitgold network, solved problems would be sent to a Byzantine fault-tolerant public registry and assigned to the public key of the solver. This is basically Bitcoin. So what changes? Huh. Okay, my question is, what is the thing that Bitcoin adds if Bitgold already provides the concept of proof of work, etc., right? E is an old language for smart contracts that runs on the JVM. Yo. I checked your GitHub. Yo, thank you. How do you make so many open source contributions? What? wait. What do you mean? What? Wait, I haven't contributed to open source. Like, ever. To an open source project. Like, I just have, like, my own projects, right? Like, Nalog is the one we developed on stream, and that's about it. But yeah. Yeah, I have to get involved in the world of open source, although I don't know how. But yeah. Actually running the C code could be interesting on local, yeah. How long do you think you will take building the requisite foundations as you have been doing before you start getting any significant traction on the project? Let me read Valley's message first. E is also older than you'd expect. I love how simple the web page for it is. E programming language. Gonna come out, give me a second. I just want to get this out of the way. The E language. Oh, damn. The E language tutorial. Okay, we'll take a look at it later. Alright, so Ganga Kamal, you're saying here. How long do you think you'll take building the requisite foundations, as you have been doing, before you start getting any significant traction in the project? Yeah. So basically, I think we're not going to start developing the blockchain like for some time. That is like in the next 2 weeks at least. Because we're going to be reading papers about other blockchains so that we have an idea of what do we want to implement. Right? So as you can see, we were able to just flush the Bitcoin white paper in one day. assume that the other papers are gonna take us like 2 days each, right? And the ones we have are Bitcoin, Solana, and Monero, if I remember correctly. Maybe Ethereum, right? So those three, which would just make like what, this week worth of content. And then after that, we have to start making our decisions and actually planning the project. So I would say around next week, we would start around the middle of next week or around Monday. Around Tuesday of next week. We will start sort of thinking about all of the decisions that we need to make. Like, how is a blockchain going to work? Right? What things do we integrate from other parts, etc., etc., etc. Okay. When it comes to Rust, I think I just need to learn Rust links, and definitely I will have completed Rust links by the time we have finished reading the papers, so I wouldn't worry about that too much, about the Rust part. Yeah, so I think the thing we're going to start with, which we can actually start with like right now, no need to read more papers, is the cryptography, right? Like implementing our cryptography cryptography library, right? Rust love a macro, Greenly. Didn't you learn Rust like 6 days ago? Not really, and it wasn't 6 days ago. Well, I've only done 3 streams recently. But yeah, so I learned. I wouldn't say I learned Rust, right? I've been doing Rust links, like the little guy with Visual Studio. Been doing Rust links and sort of going through the lessons. We are halfway through, so I wouldn't say I've learned Rust. We're halfway through. We're in options. Now we need to get through errors, generics, traits, lifetimes, tests, iterators, like all of this stuff, threads, macros, Clippy, and finally conversions. So we're halfway through. Yeah, I wouldn't say I know Rust. Is another language. Are you trying to get into cybersecurity? No, not really. We just considered sort of this project to be interesting. Do you program in any programming language? Yeah, yeah. Because usually you need a programming language to program, but yeah, the language I'm more used to is C++. By extension, although people are gonna burn me at the stake, C. Although I don't think that's valid. I think C has its own things, etc. But I could code in C like comfortably. You know, I feel comfortable in C. I don't feel comfortable with Rust right now. I just want to finish these lessons. Rust lower macro. My advice would be mastering the math first when going to cryptography. Yeah, that's what like the previous 7 streams have been. Us reading the Joy of Cryptography book. But yeah. Urchox. Okay, I need to learn Rust as well, man. Yo, okay, on Linux probably the best option. Yes. I thought the Rust tutorial where you just implement a linked list over and over was pretty good. Interesting. Do you have that tutorial? Because we could just use that. Makes sense that having completed Rust links by the time the blockchain was... Yeah, assumes you'll do all of Rust links on stream, or you'll complete also stream as well. I think I'll do Rust links on stream. I think it's a good idea to just do it off stream as well, just to not bury anyone in like a bunch of lessons, right? But yeah, I think I'll do some off stream. How do you think I get into open source? I tried it, so overwhelming. I have no idea, because I have no open source contributions. I have not contributed to open source either. I have public projects, but that is very far away from open source. Like contributing to open source. So yeah. Here it is. Okay. We have the link, people. We have the link. Let's see. Hey man, but without AIs and agents and LLMs, true. This guy knows what we're talking about. Yeah. Yeah. Okay. Okay. We're going to take a look at the tutorial. I want to take a look at this tutorial with entirely too many linked lists. Okay. I think I hate linked lists with a passion. Terrible data structures. I see. Okay. Wait, this is interesting. Mumble, kernel embedded something intrusive. Okay. Wait, this is great. This is great. I think we can follow this tutorial. I do want to do a little bit of Rostlings because like I need to learn at least the syntax of some stuff. I want to get at least to lifetime. So that to get to lifetime. I feel that's like the end of the core concepts. The rest are like tests, iterators, strats, macros, right? And we're only like 4 lessons away, which is very, like, these lessons are completed very easily. They do overstate how rare intrusive linked lists are. Interesting. That surprises me. Intrusive linked lists seems to be very common actually, no? At least from our work with the memory allocator, like, we were doing red-black trees, like, all over the place. Intrusive red-black trees. Anyways, but yeah, let's see. Errors 1. This function refuses to generate text to be printed on a name tag if you pass it an empty string. It would be nicer if it explained what the problem was instead of just returning none. Thankfully, Ronst has a similar construct to option that can be used to express error conditions. Change the function signature and body to return result string instead of option string. Okay. Result string instead of that. Okay, great. Empty names aren't allowed. Let's take a look at this. Generates name tag text for a non-empty name. So what did they expect? They expect generating a name tag text and saying, okay, hi, my name is Beyonce. And the error should look like whatever this is. Error. Empty names aren't allowed. Okay, so I imagine that I can just do empty names aren't allowed, so then I just say error. Empty names aren't allowed. Yes. And then I can just, what? Return that? Expected string found. Okay, yes. String from this thing. And then I imagine I could just do okay of this guy. So return okay of this guy. Yay! Okay, wait. I forgot to initialize Rostlings. Yay. Errors 2. Let's see. Just a quick question. Do you like the video games or just programming? What do you mean the video games? Do you like the video games or just programming? Do you mean like, do I like video games too or just programming? If it is the first one of do I like video games, I mean, I feel, a lot of, everybody loves video games. Like I like video games. I don't play many video games though. The only video games I play are like Rocket League. That's it. And I played very frequently. And like I have like Clash Royale on my phone. But that's about it. Yeah. That's a pretty terrible transformation, honestly. Are you are you talking about the thing I just wrote? Wait, what do you mean? Oh no. Is Valley just okay. Damn. Okay, thanks for okay. The tutorial, yeah, it's not your fault. Okay. Yeah. We're gonna take a look at the linked list and then I think you'll be more happy. Say we're writing a game where you can buy items with tokens. All items cost 5 tokens, and whenever you purchase items, there is a processing fee of 1 token. A player of the game will type in how many items they want to buy, and the total cost function will calculate the total cost of the items. Since the player typed in the quantity, we get it as a string. They might have typed anything, not just numbers. Right now, this function isn't handling the error case at all. What we want to do is, if we call the total cost function on a string that is not a number, that function will return a pass-int error. In that case, we want to immediately return that error from a function and not try to multiply and add. There are at least 2 ways to implement this that are both correct, but one is a lot shorter. Handle the error case as described above. Okay, so we pass this, right? And so now I need to know error handling in Rust. How does that even work? Errors are a fact of life in software, so Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. This is actually great. Another Rust W. Rare Rust W. Very rare among all of the else Rust has been taken as we've been learning it. There's some things I don't like, but this I like. This requirement makes your program more robust by ensuring that you'll discover errors and handle them appropriately before deploying your code to production. This is excellent. Rust groups errors in 2 major categories: recoverable and unrecoverable errors. For recoverable errors, such as file not found, we most likely just want to report the problem to the user and retry the operation. Unrecoverable errors are always symptoms of bugs, such as trying to access a location beyond the end of an array, and so we want to immediately stop the program. Most languages don't distinguish between these 2 kinds of errors and handle both in the same way, using mechanisms such as exceptions. Rust doesn't have exceptions. Instead, it has the type result, TE, for recoverable errors, and the panic macro that stops execution when the program encounters an unrecoverable error. This chapter covers calling panic first and then talks about returning result values. Additionally, we'll explore considerations when deciding whether to try to recover from an error to stop execution. I'm not very interested in this one. Can you run the program with something like this? Call to panic causes the error message containing the last 2 lines. File name, yes. Here we're attempting in C. Isn't fine behavior. You might hit whatever is at the location of memory to protect your program from the sort of vulnerability. Okay. Yes. The note. Okay. That's a lot of output. Okay. Okay. Yeah. We don't really. Okay. Recoverable errors with result. Okay. Most errors aren't serious enough to require the program to stop in time. Sometimes when a function fails, it's for a reason that you can easily interpret and respond to. For example, if you try to open a file and that operation fails because the file doesn't exist, you might want to create the file instead of terminating the process. Recall from handling potential failure with a result in chapter 2 that the result enum is defined as having 2 variants, OK and error, as follows. I feel this is so great. Like, I cannot emphasize how happy I am about the fact that Rust took some types seriously. I am really excited about that specific feature. The rest of the language, but this feature. The T and E are generic type parameters. We'll discuss generics in more detail in chapter 10. What you need to know right now is that t represents the type of the value that will be returned in a success case within the OK variant, and e represents the type of the error that will be returned in a failure case within the error variant. Okay. Because result has these generic type parameters, we can use it. Yes, makes sense. Call a function around. Yes. The return type. Yes. Contains more information. Yes. We need to add to the code in this thing. Returns listing user basic tool. The match expression that we discussed. Okay, so I can just use a match expression. Okay. So we can just. Okay. Oh, that's great. I guess that's, yeah. I guess I don't know what else I expected, given that the result type is just a subtype, but it's okay. I'm curious, where do you know subtypes from originally? I took a programming language design course, so we were learning about all of the primitives when it comes to designing a programming language, and one of the things we learned about was subtypes. Sort of the match expression in a sense. Yeah, I remember writing like a little programming language, and yeah, and a very small sort of parser for it and all of that. So C++ also has sometimes they are called union and high. Actually, no, I wouldn't say so. I would say that the union in C++, I would not consider it to be a subtype. I feel it's actually kind of far away from what a subtype should be. But yeah, it's just it has. I guess it has a similarity in the sense that it's a single type that can store sort of. It's a type that represents a possibility of multiple types. Yes, but I wouldn't call it a subtype equivalent per se. Maybe someone with more knowledge in programming language design let us know. But yeah, and hi Rudyfan, welcome back. We're here looking at how to deal with errors in Rust. It seems like you match on different errors, and so the way to do this. Okay, unwrap or else. This is interesting. Okay. Add C++ unions, C unions. Those aren't sometimes. Yeah, exactly. I would feel it's pretty far away from a subtype actually. It shares the sort of notion of a union can store multiple things, but I wouldn't call it. Union bool char has different possible states. True. True. But I wouldn't say because a subtype is I wouldn't define a subtype as possibilities, right? There's no tag. 2 + 256. Yeah. Yum. Alright. Okay. So we also have this possibility, unwrap or else. Shortcuts for panic on error. Yeah, okay. Let's just go back. So I think we now know how to do this. We can just use the match expression for the quantity. Where we can do okay. Let's just call it Q. And then we do whatever we need. And then we can do the error type. Error and then error. And so with OK, what we want to do, if we want to return that error too, so we're going to do return, oh, sorry. What are we doing? Quantity? Oh, I guess, yeah, I guess we just return whatever this guy is. We move this guy somewhere else. And then we return for the error, we just return error. Yay. And this would be Q. Great! So that would be one possibility. What's the other possibility? The other possibility would be something like QT and then unwrap or else. Okay, I see the convenience of the unwrap or else. But, and then we create a lambda function, right? That's what we have here. Where we just say error. Then all I do is say return. Well, can I return? I cannot really return from here, right? Unwrap or else, yeah, here. I could panic, but I don't think I can return. Like, because I don't want to return from the lambda. I want to return from the actual function out here. So I don't think I can do that. I think I'm forced to follow the match instead. Maybe. Okay. That's fine though. Let's see. Oh shoot, discussion. Okay. Those states overlap since there's no tag. There's exactly 256 states. No, they don't. A union with the first member active is different from a union with the second member active. Not at runtime though, which is important if you want sometimes. Some types. Yeah. You can run a context with function to calculate the tag if you want. Let's see. So i32 is like an int 32. Yes, yes, exactly. So you can do like let Olaf i64, and then that's it, right? And then i28 also exists. 256 I think doesn't, because that's ridiculous. But yeah, pretty good. Yes, and the same for unsigned integers. Yay! All right, exercise solved. Errors 3. Okay, this is a program that's trying to use a completed version of the total cost function from the previous exercise. It's not working though. Why not? What should we do to fix it? Okay, we have an error. It says the than operator can only be used in a function that returns result or option. This function should return result or option to accept this guy. Oh, so it forces you to deal with the errors eventually. That's so funny. Okay, that's pretty good. Consider adding the return type. Oh, what? Fix the compiler error by changing the signature and body of the main function. Oh no, wait. Well, I guess this is the way you output errors to standard error. I don't know, right? But like, ooh, I feel very uncomfortable doing this. Because it's like, I am not being forced to handle the error per se. Like, I kind of am because I need to, you know, modify the signature of the function and all of that. But wait, sorry, I forgot what the signature they suggested was. Box, Dean, STD. I still have no idea what box means. They haven't taught me that, so box, Dean, STD error. Okay. To return the result of this, and then box, Dean, STD error. Okay, what expected enum this guy Oh shoot, I included an extra guy now. Oh no, there is no extra guy. Wait, what? I'm doing the right thing, right? Expected result, this guy found this much. What? So do I just do okay and that's it? I don't think that's what they wanted to do. Right? This would be more like an error. No, okay. What? So what about... Huh? Okay, I guess. Anyways. Yes, okay, thanks also. It's worth noting that division in specific is really slow with I-128. I see. Question mark is kind of like explicit exception unwinding. I see. I think it's for type safe or something like that. The result probably a good practice. Yeah, I agree. So the point is develop like a wallet with Rust or a transactional system. So the point of the well, do you mean like this guy? Or do you mean like the overall project and stream? If you mean the overall project on stream, the goal is to create an entire, like a blockchain, right? So everything related to the software for the nodes, the software for, right? All of that. Not a big fan of the box errors pattern in Rust. I see. Let's see, errors 4. Next. Okay, what is this guy? Partially Q. Oh no, oh no. Oh, it's partial. Okay, and that's fine. What is the error? To do this function shouldn't always return an okay. Read the tests below to clarify what should be returned. Oh my god. Assert equal positive non-zero integer. New 10. Okay. Positive non-zero integer. New 10. Negative. Okay. Positive non-zero integer. Creation error 0. Okay. That seems very fine. Okay, so what we need to do is, if the value that you have is smaller than 0, then we need to return an error that says creation error negative, and then otherwise we need to return, not otherwise, else if the value equals 0, then I return the error for creation error. I like this. I feel like I like a lot the enums in Rust. They're very cool. Unnecessary parentheses, brother, please let me put my parentheses. It's okay. Great. And then we just do okay. Yippee. Next. Errors 5. This exercise is an alter version of the errors 4 exercise. It uses some concepts that we won't get up to until later in the course, like box and the from trait. It's not important to understand them in detail right now, but you can read it ahead if you like. For now, think of the box Dean question marks type as an I want anything that does question mark type. In short, this particular use case for boxes is when you want to own a value and you care only that it is a type which implements a particular trait. Oh, so this is like duck typing. Okay. To do so, the box is declared as a type boxed in trait, where trait is the trait the compiler looks for on any value used in the context. For this exercise, that context is the potential errors which can be returned in a result. Okay. Let's see. Sure, a lot of work, man. If you need some help, please tell me. We can learn Rust and blockchain as well. Yo, let's go. A boxed-in error is basically a fat pointer to something implemented in the error interface. People like it because it's compatible with all error types, so you can always bubble up errors. No! It defeats the entire purpose! It defeats the... Well, it doesn't defeat it, right? But, like, it would be ideal for you to deal with errors, so if people just bubble it up, then... Man, are you developing locally, or are you working remotely on a server? No, locally. We're just gonna do it locally. Yeah. Let's see. Okay. So can we see this is required so the creation error can implement error? What the hell? Import display for creation error. What the hell? Okay. Import error for creation error. Okay. Struct positive non-zero integer. It's this guy. Add the correct return type. Result boxed in. What can we use to describe both errors? Is there a trait which both errors implement? So I imagine I have to return it here. Right, so it would be result, which has this thing, and then box, din, and oh shoot, it's not parentheses, it's little guys. The angles. Okay, box din is there a trait they implement. I don't know what traits are, but that's okay, I suppose. What? Implement display for creation error. So it says it's not important to understand them in detail right now, but you can read ahead. The error trait? Like, I don't know what. Implementation error for creation error. Positive non-zero integer. Okay, I see creation error being right. Is this a trait? I imagine it is a trait. I don't know. What can we use to describe both errors? Is there a trait which both errors implement? Yeah, the error trait, right? Is that a trait? Is this what I'm supposed to use? Maybe. Seems like it. Okay. Let's see. It's just a question. Is possible a good idea to develop into a remote server? Yeah, that's true. I usually, when I'm in college, I sometimes develop through the university's remote servers because they're like fast and it's sometimes a little bit better. I do like to develop locally though. I feel like a computer is also fast and I have control over it. Is it? It's worth noting that boxed errors make it equivalently more frictionful to match on errors. That's no worry because no one handles errors anyway. Service has more resources and the blockchain requires resources than the machine. Yeah. Could be something like that. Although, like, maybe the resources would be required to deploy or something like that. I don't think we're gonna be doing something very hard that would require us to have an extra server. I think I can just use my computer. But yeah, let's go through N. Okay, last errors. Using catch-all error types like boxed-in error isn't recommended for library code, where callers may want to make decisions based on the error content instead of printing it out or propagating it further. Here, we define a custom error type to make it possible for callers to decide what to do next when a function returns an error. Okay, so creation error is the custom error type. Pass post non-zero error. Pass function from creation. Is this just like a guy that lets me... Is this just like the implied conversion constructor like in C++? From parse int, probably, yeah. and then I accept an error that just accepts parseInt error. Then I return self. It's like a factory of sorts. So I can just say self, parseInt, and then I return error. Right? And that's it. No. Okay. Well, I just did that. What? Okay. Positive non-zero integer. Do I need to modify anything else? Possible non-zero error creation. Creation negative, creation error 0. Wait, did they ask me to only add a single one? Wait, yeah, from parseInt. So what am I... Huh? What am I supposed to do? Positive non-zero integer. We implement the new function. The pass function. Oh, there's a to-do. Change this to return an appropriate error instead of panicking. When pass returns an error. Okay, so we don't unwrap because that's for people that want to take down Cloudflare. We instead are responsible and match on the value of x, right? And then we say, okay, x implies us returning x, right? Like, I don't, but, right? Mismatch types, I64. Yeah, so I think this guy may just be maybe like this, right? I know this is not good naming, but like this is just a random exercise, so don't worry. Then I want to return x, and then all I return is x, and then inside of error of x, inside of error where I get the error, I just return the error. I don't think this is allowed. Oh, what? The trait bound from SDR is not satisfied. Defining other types. What? Okay, no. I'm doing everything wrong. Change this to return an appropriate error instead of panicking. When pass returns an error. So this will return whatever pass returns, which is a result of some sort. Yes, right. And then what I can do is I can match. Right? Match x, and then, well, I'm gonna end up doing the same thing. Value, and then I just return what? The value? X. To return an appropriate error, return x. Return x. I prefer when I put brackets around it. Yes, and then error of that error, right? Are you using Git? Not right now. I'm gonna be using Git for the project, of course, and it's gonna be public, so you guys will be able to see it. But yeah. Return. What am I supposed to return? I am so confused. What do they want me to do here? Changes to return an appropriate error instead of panicking. So if there's an error, I imagine that what I need to return is parseInt error. What? The trait bound, what, huh? Okay, what is parse? What? What? Pause. Yeah, pause, non-zero error. right? And then I just, what am I supposed to do? Creation or parse int. So in this case, it would be parse int error, right? What else are you expecting from me? I imagine you have to return password some kind of error. Yeah. Some error kind. Yeah, that's what I'm. That's what I'm trying to do, but I don't understand like parse int error. So then do I just do like parse int error and then? Oh, error. No. No, okay, what is the type of this guy? A parse pause non-zero error. What? How is this a parse pause non-zero error? Isn't parse a function from the Rust side? Okay. I don't understand this. What are we doing here? Why are things the way they are? Oh, you need to wrap the error returned from parse inside parse pause non-zero error complete. Non-zero error. Really? Like creation and then error? Because that's what I've been trying to do, right? I've been wrapping the error into a parse int. Because parse int error, right, it's something that should be accepted, right? Oh, is it something like this? Parse pause non-zero error, and then I just do this? No. Do I say from parse int? No! What? What is going on? Because parse just returns F error. Parse was non-zero error is a wrapper, I think. Parse pause non-zero error. Yeah, is this guy, right? And so before, this is a parse int. Yeah. And I agree it's cursed. Like, parse pause non-zero error. Because I don't understand what you want me to do. From percent. Like, what? Do I pass X to it? No, I pass error. Okay, I really give up on this one hint. This exercise uses a completed version of positive non-zero integer from the previous exercises. Below the line that to-do asks us to change, there is an example of using the map error method on a result to transform one type of error into another. Try using something similar on the result from past. You can then use this operator to return early. Read more about map error. Okay, so screw all of this. Put on wrap. Right? So my question here is, what are we doing? What are we doing? So where is the hint again? Here. Result to transform one type of error into another. So there's this map error guy, right? When I unwrap this, I get a number, but I don't want to get a number. What I want to do is I want to get the result, but with the error and everything. I'm going to end up writing the same code. No, okay, X means that I need to return X. Otherwise, error for the error means that I need to return an error, right? So then the error that I need to return is a parse pause non-zero error, this guy, and then I need to detect whether it's a creation error or a parsing error. You're supposed to change map error off the parse call, I think. Oh, dot map error, and then I do a parse error or parse plus non-zero. Parse plus non-zero error. Parse plus non-zero error. Like that, and then from parse int, and then I just delete this line, and then I just return x. And then I can just do this. The trait bound result positive non-zero integer parse plus from string is not satisfying the following other types. Implement trait from string. What do you mean? What do you mean? Like, what do you mean? Question mark? What? The trait bound positive non-zero integer. Try adding an I64 type annotation to X. You made it worse! You made it worse. Do I add a... Oh my god. I think it works. Yes! And then I do OKX. Oh shoot. Mismatch types. Expected positive non-zero integer found this guy. Oh well. I can just wrap it, right? Oh, I see. Let y be equal to okay. Parse what's the name? Positive non-zero integer, right? And then I perform the conversion where I say how do I convert? Well, I guess I can just do this. I just do x, right? And this guy is equal to that. Mismatch type U64 found I64. What am I supposed to do? What? No, you're lying. You're lying. He accepts an I64. Oh wait, new. Okay, and then this is probably gonna throw an error. If it throws an error, then I'm gonna map that error to be parse plus non-zero error creation, and then I'm going to just, you know, map out the error. And then if there's an error here, I'm gonna return early. Finally, I return y. Did we succeed? Oh my god, let's go. Oh my god, let's go. Dude, this was going so bad. I hated number 6. Golf clap. Let's go. Yay. Okay, next. Generics. Les generics. What was the change? Oh, I don't know. They just gave us some cancerous instructions. Like, genuinely. Okay, but yeah, it was just like mapping the error to whatever this was, and then like this guy, and then map error, and then return okay. Don't worry about it because I don't want to worry about it. Yeah. Let's see. Vec T is generic over the type T. In most cases, the compiler is able to infer T, for example, after pushing a value with a concrete type to the vector. But in this case, the compiler needs some help through a type annotation. To do, fix the compiler error by annotating the type of the vector. Vec T shoots. T is some integer type that can be created from U8 and I8. So do I just do this? I8. Comparison operators cannot be changed. Oh, I think Rust has it so that it's really weird, and this also involves a colon. Yeah, okay. Created from U8 and I8. Oh, okay. Yeah, I don't know such type. I32? Yeah, okay, that sounds about right. Yay, generics. Yay, generics. Does Rust not have multi-line comments, or does the author of the tutorial just not use them? That is a great question. Let me try it out. I mean, it has to have multi-line comments. If not, I'm gonna be very mad. Yeah, seems like it has them. So I don't know. Maybe it's a stylistic choice, because I feel it looks like a little bar. I feel I like this. I feel I like them being like that. But it does leave you thinking. But yeah. This powerful wrapper provides the ability to store a positive integer type, a positive integer value. Rewrite it using a generic so that it supports wrapping any type. Okay, let's take a look. Can we know how? Oh shoot. Okay. How? Okay. Let's guess the syntax of generic. So I imagine it's the same as C++, where I just do wrapper T, and then I just do T. And then I just say T. Oh shoot. Okay, well, yeah, what am I supposed to do? Like, 2 dots? Not found in the scope. Okay. Generics in Rust. Yay. Function definitions. So here, yes. This guy, T. Well, I think we're fine, right? Instruct definitions, yes, this makes sense. Tell me how it works in the implementation. So, I imagine maybe it doesn't go here and instead it goes here. Missing generics. Oh my god. Brother, leave me alone, please. Implement T. Oh my god, dude. Okay, let's read the book. Impl T, wrapper T. Oh, really? That is such a bad design. What the hell? Why would you want it to be that way? Why specify it on both parts? Yeah, that's very bad. Damn. Well, another thing I don't like. Impl T. Well, actually, no. Okay. I can see a world of possibilities where you do like, can you do something like this? Impl I32 wrapper for like, actually no, that's dumb, right? Because like, why do I need to specify it in both places if they in the end need to agree? Or can these two disagree? If so, I would like to know, because like, what would be the weird case that takes us to this being different than the one on the front? I don't know. We'll see. There's a reason, but I don't know from memory. Okay, but there is a reason. It's good to know. Let's go to traits. I think we're gonna be able to finish today. I want to finish this today. So let's go. Lifetimes, traits. Maybe once we finish lifetimes, we can end the stream. Let's see. The trait append bar has only one function, which appends bar to any object implementing this trait. Okay. Implement append bar full string. Okay, so then what I need to do is function append bar. So all I do is self and then self. And then I return self plus equal bar. and then I do string from. No. Okay. Oh, sorry. This. No. Okay. This. Yes. Yippee. Output foo ball. Oh, it's supposed to be with caps. Perfect. We want next. Traits 2. Trait append bar. Implement the trait append bar for vector strings. Append bar should push the string bar into the vector. Okay. So then I imagine I just do implement append bar for the vector class. A vector, and then I just say t for some random guy. Okay. So it's telling me, oh yeah, you don't have append bar. Okay, append bar. Self, and then all I do is I say self dot push the value bar, and then just return self. Yo, and I imagine import t is necessary here. Can I just write vec? Is that a thing? No. Okay. So, do I need to append the guys to every single thing that I'm talking about? No. Okay. So it just says mismatch types, expected type parameter t, found reference, static string. Oh, I have vector strings. So that means I can just do this. And so I push a string from this guy, and we all are happy. What? What am I supposed to do? Okay, mismatch types, expected type, parameter string, found reference. What? Bar mentioned. Yo. Yeah, we are in a little bit of a conundrum. What do we do? Let's see. Append bar is self, which would be the vector string, dot push, and then I push a string from bar. Right. So what else? Give me a second. I need to set an alarm. Real quick. 3:02 p.m. Rescue G drive. Perfect. Okay. So I need to append bar, but like, is this not the way I do? Okay, let me read the compiler. So it says expected this type parameter. Expected type parameter string found this guy. Don't you see that I can just do this guy and then it's gonna be fine? I should be able to write this. Why does it not write it? Why? Why is it not letting me convert stuff into what I want? Yeah, what the hell? String from boo, yeah. So the vector is going to be a string vector. Do we know what's going on? So I'm genuinely going to do something to the creators of Rust. Except type parameter string found this guy. the string does not implement the from string. That trait, like, what am I? Okay, it seems to be working. Cannot borrow self as mutable, as it is not declared as mutable. Cannot borrow as mutable. Cannot borrow as mutable. So it cannot mutate self. So what do I do? Do I change this guy, mute self? Is this it? Yay! Yay, 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 yay. Yay. Okay. Perfect. Woohoo. Traits 3. It's a pretty cool open source real strategy. What is this? Let's take a look at what Andrew sent. Oh, bar, beyond all reason. Pretty interesting. Yo, I could not understand the reference because I didn't know what it was. Yeah, let's see. To do. Add a default implementation for licensing info so that implementators, like the two structs below, can share that default behavior without repeating a function. The defaulting license information should be the string default license. Okay. And so, do I just implement this function? No. And then I return something like yeah. No. Okay. What am I supposed to do? Oh, of course. String from. And of course, no semicolon. Oh, I see. So now I just say default license. Yay! Okay. Next, 4. Okay, license the string, yes. Fix the compiler error by only changing the signature of this function. So to compare license types, I imagine I would just need licensed, and then here licensed. Expected a type, found a trait. So how am I supposed to do, like, oh, I don't care. I find, oh, this is where din comes in. Okay, let me see. Let's read the compiler error. Expected a find a trait. Use a new generic type parameter constrained by licensed. That's a possibility, okay. You can also use an opaque type, but users won't be able to specify the type parameter when calling a function having to rely exclusively on type interface. Alternatively, use a trait object to accept any type that implements license, accessing its methods at runtime using dynamic dispatch. Oh, let's do that. Din, and then din. Arguments, this function occurred, expected. Found struct, expected reference, din license, found struct of the software. Wait, but they implement the trait, so what are we doing? Hello? Guys, what's wrong? Okay, what? Ross is so frustrating. Okay, consider borrowing here. Oh. Wait, so maybe I can just not borrow and just use din without the ampersand guy? Like this? Oh shoot. The size for values of type this cannot be known in compile time. The trait size is not implemented for this guy. Okay, so I assume I do this. I then do this, and then I do this, and this and that. Yay! Okay, next. Traits 5, last one of traits, and then we transition to lifetimes, which are only 3. And then we finish. Yay! Fix the compile error by only changing the signature of this function. Oh wait, was number 4 also that instruction? Oh, only changing the signature of that function, so sorry about that. So I think we're gonna have to opt for the generic license. And then I just do these two guys change to T. No. Oh my god. Oh, never mind. I forgot. Oh no, I hate you so much. Dude. Some software found. What did you find? Found other software. Do I have to create the generics? What? Okay. TS license. Wait, is this what they want me to do? Well, seems like it. Okay. Traits 5. Fix the compiler error by only changing the signature of this function. The error is cannot find value item in this scope. Oh, of course. So what do we need to do? Item sum function, other function. Okay. So the other trait and the sum trait. Implement the sum trait and the other trait for sum struct. Other struct. Okay. So item should be what? Okay. Accept things with multiple traits in as function parameter in Rust. Clone pattern like color pattern. No, this isn't what I'm. Yes, okay. Swimmer, walk, energy. Mute then walker. Oh, I guess in this case I could either use Repsol with trade bounds. Oh, so I do this. I do plus. Ah. Okay, so can I do din sum trait plus din other trait? Okay, no, I can do what the guy was doing, where I do a T and I say T. Yo, perfect. Completed. Next. Final ones, lifetimes. Okay, lifetimes. First, the Rust compiler needs to know how to check whether supplied references are valid, so that it can let the programmer know if a reference is at risk of going out of scope before it is used. Remember, references are borrows. And do not own their data. What if their owner goes out of scope? Okay, with won't work with din. For din, you will need to declare trait explicitly beforehand. I see. Okay. Okay. Let's see. Fix the compiler error by adopting the function signature. What if their owner goes out of scope? I mean, I agree, but what are we doing? What? Okay, so I'm supposed to, okay, lifetimes in Rust. Dude, Rustlings doesn't teach me much. I'm so happy we're gonna be done with the Rustlings. I don't wanna keep going. Lifetimes. A lifetime is a construct the compiler, or specifically its borrow checker, uses to ensure all borrows are valid. Specifically, a variable's lifetime begins when it is created and ends when it is destroyed. While lifetimes and scopes are often referred to together, they are not the same. Take, for example, the case where we borrow a variable via ampersand. The borrow has a lifetime that is determined by where it is declared. As a result, the borrow is valid as long as it ends before the lender is destroyed. True. However, the scope of the borrow is determined by where the reference is used. In the following example and the rest of the section, we will see how lifetimes relate to scopes, as well as how they two differ. So maybe this is the lifetime. Okay. Makes sense. How do I write lifetimes? The borrow checker uses explicit lifetime annotations to determine how long references should be valid. In cases where lifetimes are not elided, Rust requires explicit annotations to determine what the lifetime of a reference should be. The syntax for explicitly annotating a lifetime uses an apostrophe character as follows. So foo has a lifetime parameter prime a. I see. Didn't create virtual table for trait you specify, and it can't create table for anonymous trait combination. Ah, that's a pretty good explanation for why didn't cannot be used. Thank you. Rudifant says, lifetimes have the worst syntax Rust came up with. Oh no! In cases with multiple lifetimes, the syntax is similar. In this case, the lifetime of foo cannot exceed that of either prime A or prime B. See the following example. Create variables to be borrowed, 49 here. Then print refs. So we do this, and we print. Any input which is borrowed must outlive the borrower. In other words, the lifetime of 4 and 9 must be longer than that of print refs. What? Print refs is a function. What do you mean it's lifetime? Are function values in Rust? Is this another Rust value? Like another Rust value, W? You can use this, rustcurious.com. Yo. Okay, we could take a look at this. But I think I'm gonna continue with the Rustlings. I see the course is not yet complete. But yeah, I'll take a look at it in my free time. In the meantime, I think I'm gonna... Okay, I want to understand this. Failed borrow. Why? It contains no references to force prime A to be longer than the lifetime of the function, but prime A is longer. Because the lifetime is never going to... What? Failed borrow. Prime A. So prime A is just like a lifetime variable? What? Oh, thank you, Andrew. Take a look at it, but I don't understand. Okay. X12. Error. X does not live long enough. What do you mean it doesn't live long enough? Y is equal to that guy. Oh, okay, never mind. Okay. Okay. So prime A and prime B are like global variables that I can just use in lifetime annotations, right? But like, how do we determine who prime A is or refers to? Did it refer to 4 and then 9? But then, I mean, there's still... Okay, this code does not contain any reference to 4, any reference to 9, nothing, so they died here. So failed borrow. Yeah, I don't understand this. What the hell? This is like the actual worst example you could have given me. Yeah, I want the Ross book. Oh no. What? Ross semantics are such that it can figure out if arbitrary rules are satisfied on a per function basis. Wait, but like, lifetimes are another kind of generic that we've already been using. Rather than ensuring that a type has the behavior we want, lifetimes ensure that references are valid as long as we need them to be. One detail we didn't discuss in the references and barring section is that every reference in Rust has a lifetime, which is the scope for which that reference is valid. Most of the time, lifetimes are implicit and inferred, just like most of the time types are inferred. We're only required to annotate types when multiple types are possible. In a similar way, we must annotate lifetimes when the lifetimes of references could be related in a few different ways. Rust requires us to annotate the relationship using generic lifetime parameters to ensure that the actual references used at runtime will definitely be valid. Annotating lifetimes is not even a concept most other programming languages have, so this is going to feel unfamiliar. Although we won't cover lifetimes in their entirety in this chapter, we'll discuss common ways you might encounter lifetime syntax so that you can get comfortable with the concept. Dangling references. The main aim of lifetimes is to prevent dangling references, which, if they were allowed to exist, would cause a program to reference data other than the data it's intended to reference. Consider the program in here, which has an outer scope and an inner scope. Yes. And it's said to use a reference whose value has gone out of scope. A reference whose value has gone out of scope. Oh, okay, we let R be this. We grab X, and so X still has a borrower. And so it remains alive, and so now it's used. Okay, I see. The outer scope declares a variable named R with no initial value, and the inner scope declares a variable named X with the initial value 5. Inside the inner scope, we attempt to set the value of R as a reference to X, then the inner scope ends, and we attempt to print the value in R. This code won't compile because the value that R is referring to has gone out of scope before we try to use it. Here is the error message. The error message says that the variable X does not live long enough. Okay, so if this wasn't a borrow, but instead a move, we would be completely fine. I am understanding. I hope. The reason is that X will be out of scope when the inner scope ends on line 7, but R is still valid from the outer scope, because its scope is larger. We say that it lives longer. If Rust allowed this code to work, R would be referencing memory that was deallocated when X went out of scope, and anything we tried to do with R wouldn't work correctly. So how does Rust determine that this code is invalid? It uses a borrow checker. The Rust compiler has a borrow checker that compares scopes to determine whether all borrows are valid. This listing shows the same code as here, but with annotations showing the lifetimes of variables. Yeah, that makes sense. Here we've annotated the lifetime of R with prime A and the lifetime of X with prime B. As you can see, the inner prime B block is much smaller than the outer prime A lifetime block. At compile time, Rust compares the size of the two lifetimes and sees that R has a lifetime of prime A, but that it refers to memory with a lifetime of prime B. The program is rejected because prime B is shorter than prime A. The subject of the reference doesn't live as long as the reference. Okay, yeah. Here X has the lifetime prime B, which includes, yeah. We'll write a function that returns the longer of two string sizes. This function will take two string sizes and return a single string size. After we've implemented the longest function, the code in this listing should print the longest string as ABCD. Yes, I agree. Note that we want the function to take string sizes, which are references, rather than strings, because we don't want the longest function to take ownership of its parameters. Refer to string slices as parameters in chapter 4 for more discussion about why the parameters we use in listing this are the ones we want. Okay. If we try to implement the longest function as shown in listing this, it won't compile. Why? Instead, we get the following error that talks about lifetimes. Okay, this function's return time contains a borrowed value, but the signature does help. Does, okay. The help text reveals that the return type needs a generic lifetime parameter on it because Ross can't tell whether the reference being returned refers to X or Y. Oh, I see. So if I return a reference, I would, in a sense, be keeping alive one of the parameters. So Ross needs to know that I am keeping it alive. Okay. Actually, okay, Ross can't tell the difference. Actually, we don't know either, because the if block in the body of this function returns a reference to X, and the X block, the else block returns a reference to Y. When we're defining this function, we don't know the complete values that will be passed into this function. So we don't know whether the if case or the else case will execute. We also don't know the complete lifetimes of the references that will be passed in. So we can't look at scopes as we did in this standard to determine whether the reference we return will always be valid. The borrow checker can't determine this either because it doesn't know how the lifetimes of X and Y relate to the lifetime of the return value. To fix this error, we'll add generic lifetime parameters that define the relationship between the references so that the borrow checker can perform its analysis. Lifetime annotation syntax. Okay, lifetime annotations don't change how long any of the references live. Rather, they describe the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. Just as functions can accept any type when the signature specifies a generic type parameter, functions can accept references with any lifetime by specifying a generic lifetime parameter. Lifetime annotations have slightly unusual syntax. Slightly unusual, referring to the syntax they themselves chose. The names of lifetime parameters must start with an apostrophe and are usually all lowercase and very short, generic types. Most people use the name A for the first lifetime annotation. We place lifetime parameter annotations after the ampersand of a reference, using a space to separate the annotation from the reference's type. Okay. One lifetime annotation by itself doesn't have much meaning because the annotations are meant to tell us how generic lifetime parameters of multiple references relate to each other. Let's examine how the lifetime annotations relate to each other in the context of the longest function. In function signatures, right? Rust lifetimes are hard to grasp. Hi, Basapenda. Thank you. Welcome to chat. And yeah, that's what I'm trying to grasp. To use lifetime annotations in function signatures, we need to derive the generic lifetime parameters inside angle brackets. Declare, sorry. The generic lifetime parameters inside angle brackets between the function name and the parameter list, just as we did with generic type parameters. We want the signature to express the following constraint. The returned reference will be valid as long as both of the parameters are valid. Okay. I see you. Okay. I feel like I understand. So what that means is longest. I don't know what it's going to return, which means I need to add a lifetime annotation that tells me this is one lifetime. I forget the syntax. I think it's like this. This lifetime is going to be the same here. I kind of don't care. And then this guy's going to live as much as the lifetime parameter A. Right? I think this is... Oh shoot, we need to do the quiz. Quiz 3. This quiz tests generics and then traits. Okay. Doing good. How are you? Are you learning Rust? Yes, I'm learning Rust. Yay, I'm good too. Thank you. The borrow checker is both function. Yes, all signatures are evaluated and then function bodies can be checked in parallel. Ah, okay. What distro are you running? Arch? Yes. I'm using Linux. And Arch Linux, but yeah. Imaginary Magical School has a new report card generation system. Arch, by the way, yeah. A new report card generation system written in Rust. Currently, the system only supports creating report cards where the student's grade is represented numerically. However, the school also issues alphabetical grades and needs to be able to print both types of report card. Make the necessary code changes in the struct report card and the impl block to support alphabetical report cards in addition to numerical ones. Okay, struct report card, so then I imagine we'll have to do a T, and this guy accepts any sort of thing you want. To implement something for report code, we need the generic guy too, and then we need adjust the impl block scope above, print, right, format this guy, self.grade, okay. T doesn't implement std format display. Wait, and so how can I restrict this to be just strings and floats? Like, can I do that? Do something like T string plus float, or like F32, and I just say T. Expected trait found struct string. Oh, can I not combine like types this way? Never mind, you said the same thing as me. I just misread. Oh wait, just misread your message. Oh, with reference to what Andrew was saying. Okay. Okay, expected trait found struct string. Report card. It's string plus if the, because I could just accept a normal generic, right? And then that'd be fine, allegedly. But then here what? Yeah, what am I supposed to do? You could use this guy, okay. So can I just do that? But then I didn't implement any traits. Yeah, no, what? Because this is not a trait, right? So do I have to implement the traits for what? Okay, don't understand what I'm supposed to do. Wait, give me a hint on this. I'm so tired of that not writing things. To find the best solution to this challenge, you need to recall your knowledge of traits, specifically the trait bound syntax. Here's how to specify a trait bound for an implementation block. What? Okay. Let me see if I can just vibe this out. I think I know what they're trying to tell me. Format display, right? And then I need to do something like implement, and then whatever wording they gave me. No man, I don't understand the syntax yet. Yeah, me neither. Implement. The hell? What? H, hint. Here's how to specify a trait bound for an implementation block. So this would be my report card, right? And I want this to be... Oh, wait. Are they just asking me to use display? If so, that's so stupid. Oh my god, that's so stupid. Okay, sure. Lifetime 1 we solved already. Lifetime 2 is the one we're on. Okay, lifetime 2. Don't change this function. Okay, to do fix the compiler error by moving one line. Oh, well. Okay. String 2 does not live long enough. Borrowed value does not live long enough. So I could just... So we have the longest thing here. And then what I can do is... Do you have Intel or AMD processor? I have an Intel CPU. Yeah, it's a little older, but it's okay. Let string 2 be equal to this guy. The result is equal to the longest of these two. So how... I am not going to open that link, Andrew. I am not going... Intel Nugent with IA? No, I don't think so. My processor is like a Xeon E something 23. Something like that. If I remember correctly. Can I... Wait, we learned about fast fetch last time. Is that a thing? A Xeon E5 2678. Too scared to see the truth. Andrew is you know, Andrew is giving us the arguments to you know. String 2. So we can only move one line. I mean, moving one line would be like this guy, right? And then I'm not sure if that's what they want me to do because this code is stupid, but I'll take it. Lifetime 3. Alright, last one. Lifetimes are also needed when structs hold references. Oh, fix the compiler errors about the struct. So the way I imagine this would work would be something like, I need this struct to last as long as all of you guys. Yippee! Okay, perfect. Oh my god, that was a long session. What the hell? Okay, yeah. Oof. Okay. It's because you have a server as a computer. So nice, man. Very powerful. Thank you. Yeah, it's just that like I got the processor from AliExpress. Many companies, when they need to renew the servers and stuff like that, they get rid of the CPUs and they leave them at very cheap prices. And so I bought that one, like probably like 7 years ago or something like that. Which is kind of insane, or like 6 years ago, 5 years ago. But yeah, as long as this computer has been alive. A lot of those are kind of underwhelming. Like the weird expressions? Okay, now that we finished Rust links, let's check the weird expressions. Okay. So what is this supposed to show us? Just a grab bag of stuff that you wouldn't want to actually write. And this is in the tests. So what? Okay. Function strange. Returns a bool. Oh, what the hell? Let x bool equal to return true. So I imagine the return true. What? Okay, that's funny. What? Okay, funny. Function f x nothing f return. What? Okay. Then the Return while not x.get, x.set. Why are we returning? I mean, I guess everything is an expression, right? And then it has the null value, the little parentheses value. Um, but then, why are we? Zombie G's. Oh my god, dude! I'm not reading this. Like this is just, bro. What even is this function? Okay, damn. Um, do 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 do. Do you have any graphics card? And is your ROM up to 32 gigabytes? Um, yes, I have a graphics card. It's a graphics card that I got secondhand from some random guy that needed to sell his graphics card because his girlfriend was mad at him because he was playing games. so, and so I just got his graphics card. It's like an RX 580 if I remember correctly, which is like not top notch, but not something I complain about. I really like my graphics card. I don't need to play like insane games. I just need a good graphics card, and I'm very happy with it. What do you think a server is? Dude, Valley, relax, relax. Is a server processor in the old days? Yeah. I think ear chokes just meant that like Xeons are usually used for servers. Um, but yeah, and the RAM, yes, if I remember correctly, is 32 gigabytes. Back when the RAM prices weren't so crazy, and I actually got a bundle deal on AliExpress. So the thing is, I didn't have much money, so I built this PC with like a bunch of like deals and like buying things from AliExpress and assembling it myself. Yeah, so the motherboard is like some random Huananchi motherboard from China. The processor is like an used Xeon from some company that just didn't need it anymore. Graphics card comes from the guy that his girlfriend needed to like his girlfriend was mad at him and so he sold me the graphics card. Um, yeah, I think that's about it. My keyboard is a guy that was gonna throw out his keyboard, and so I told him like, wait, no, this is a very nice keyboard. And he was like listing it in his Facebook Marketplace for free, so I just went there. Yeah, a bunch of stuff like because I usually don't have much money. Um, so you just gotta solve with what you have. My desk, for example, my desk is like somebody was moving out of their house. I didn't have a desk, and they couldn't get rid of it because it's like a big piece of furniture. So they just left it outside. So I just picked up my desk and then I brought it to my room, and now I have a desk. Like, actually, like basically, like most of the things I have, it's like people needed to get rid of them or something like that. Um, can you tell us a story on how you got into Linux? What's your first OS? Let's see. Let's see. Bro got his whole setup from China. Yo, yes, basically. Um, okay, nice. Your computer is completed. I developed by Unreal Engine. The engine was so hard by my personal computer. If you like the video loads, yeah. Okay, I imagine like a graphics card, a much more potent graphics card is required if you're developing an Unreal Engine. Um, Theodore, can you tell us a story on? Yeah. So my first OS and the only OS I had used in my entire life was Windows. Ever since I was a kid, Windows. All the way up to like, I'm currently 20, right? Up to the point where I was 20 years old, I was using Windows all the time and I loved Windows. Um, so Windows was my main thing. Yeah, Windows all the time. It's just that like I started seeing like I don't know, Microsoft has been fumbling the bag with Windows, which is very depressing. And also it's sort of like this growing concern of like, I don't know, these, it's like unreasonable to have this, but I feel I'm starting to develop that feeling where you're like, oh my god, like, right, like they're basically selling my data all the time. Or like I'm being vigilated like 24/7 through my phone, through my computer. There is no privacy in this world. Pa 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 pa. Right? And so Microsoft humbles the bag. Microsoft is a really bad company and their products are bad quality. And they're starting to push AI into the operating system. And they stopped support for Windows 10, which is what I used, forcing people to move to Windows 11. So all of those things, plus the weird sort of feeling that you get of like once you know enough, you're like, oh wait, I can actually change the fact that my data is being sold and all of this stuff. And then you get like me wanting to move to Linux and try it out. I've also heard that Linux is very good for development because one of the things that would really piss me off was like trying to set up something to develop on Windows and then Windows like completely, like Windows would just fail, right? Like developing in Windows is sometimes very annoying depending on what you want to do. Um, so I would have to sometimes use WSL. Uh, and so I said, nah, let's make the change to Linux. Like I just want to try Linux, right? Let me just take a look at it. And when deciding the distros, I sort of took a look at the distros, right? I was like, yeah, you know, bunch of distros, great. And then I looked up like what is the best distro for programming, and people said Arch Linux. They were like, oh, Arch Linux, like you gotta set it up and whatnot, but like it's good because you have control over a lot of things. So I just said, oh, great. And then I realized that like Hyperland like is mainly used in Arch Linux, and I had seen Hyperland before because of a friend, and I was amazed by it. And so then I said like, okay, let's go to Arch Linux. And then I saw the memes and everything, and that's kind of funny, but yeah, yeah. I don't know much about Arch. I just know the basics, like what gets me through, and like I just customize the little thing, not too much, but a little bit to my preference. Which Windows was your first one? It was actually Windows 7. I had a Windows 7 for a long time. So, yeah, there's this very old laptop. I would just do Windows 7 all the time there. And then after Windows 7, it was Windows 10. So I think around when I want to say 11 years old is when I started using Windows. Oh yeah. Yeah, so I think I've been using Windows 10 for like, what? Probably, yeah, like 7 years. I had been using it. 8 years. Yeah. So Windows 7, and I when I would develop, I would do it in Windows 10. So yeah, I was married to Windows, and then like every marriage, it falls apart, and so I, you know, I can't even fathom a paid operating system with tons of ads. It's like I don't know. Yeah, and especially Copilot being pushed everywhere in Windows 11, I really didn't want to change to Windows 11. Plus, apparently my computer isn't even supported by Windows 11. Like, I cannot even make the switch. But yeah, at the same time, you're not using ad blocker. Yeah, no, that's true. But like, you know, it is what I was saying. Like, it's kind of like a little stupid feeling. Like, it's not. I don't think it's a matter of ads, right? Like, I wouldn't want ads in my operating system, right? It would be very bad. Like, I just don't consider it the place to be. I do think ads have a reason to exist, right? Say you're watching a YouTube video. How else do you think the content creator gets paid, right? Like, through ads. And it would be unreasonable to say like, oh, I don't want ads here. Well, buddy, like how else do we want it? Like, right? It's being offered free. And so you can pay for a subscription if you don't want ads. But if you want it free, you need to have ads, right? In the case of the operating system, I just don't consider it, I just don't want an operating system with ads, and so I just say I switch. For content creators, I say, well, I don't really mind about the ads. I can watch them. There are some creative ads. I'm not, you know. I feel the root issue is not like ads. It would be the data that is being collected and then the ads that are being personalized for you. So what I would try to avoid, for example, would be sort of giving away your data. Right now, I am not sort of focused on that. There's many things, right? I have a YouTube account, I have Twitch, I have a bunch of stuff. But yeah, so ads I don't think are inherently bad. I would say, right? They are not inherently bad. I just don't want them in my operating system, and I have the choice to switch to a different one. I want them in my content creators because that's how they make money. Perfect for me. Could I pay for a YouTube Premium subscription? Yes, but like I say no. I mean, in this case, I don't really mind it, right? The SO that you have is so good. Arch has times so cool of updates. Tim, you have to remember the only important thing in this world, no matter what happens, no matter what, you can always resort back to the simple quote. I use what? With that simple quote right there, you will immediately gain complete dominance in every single situation you find yourself in. Have you tried the infamous Windows 8? I have. I had a laptop that I got from a programming competition once, and that one had Windows 8. I genuinely hated it. Like, it was so bad. My first one was Windows XP. Yo, and I switched to Linux when going to uni because thought it would be cool. That's another aspect that, like, if you say like, oh, I use Linux, it's like, ooh, oh my god, this guy knows well. So I don't know. Now I work with Windows 11, but it's because my personal computer is a APU. Okay, very limited in cores. I see. Wait, but actually, I feel if it's very limited in cores, you may actually want to switch to Linux, right? Because Windows Windows just blows your entire PC. But yeah, when I used Windows first time, it was just a DOS executable. Yo, wait, you've been a Windows OG. You know, the original. Always there since the birth of Windows. Well, you're at the birth, but like the early days. I think you have 8 cores almost. It's a bad reason though. You could try to virtualize any Windows if you want, but honestly, Arch is very good distro, and so yes, I agree. So I mean, the thing is like, there's really another reason why I would want that. I can use the main reason I can think of is games, but then I can just use Wine for it. Nah, it's that there is even a need for advertisement for this economy to work. That's the issue. I mean, yeah, you need the advertisement when it comes to free things. Like if you want free things, right? Is there really any other way you can do things, right? Um, what I do imagine it's like if you have a service that asks you to pay and then they show you ads, I would be mad, right? Like reasonably so, I hope. Like that would be pretty bad, but yeah. My APU has 2 cores, only physical and no virtuals or logical, but yes, Windows 11 runs so. I see. But is there anything that you hate with Linux? Yes. I would say yes. Um, there's always, at least with Arch, there's always some package somewhere that just randomly fails. Like, that would be one thing. I feel another thing is like, and I experienced this with monitors. So currently I have 2 monitors. I have one on the front, which is the one where I put the code, and I have one on the side, which is where you guys are. This is OBS in the chat, and I have the camera right here, right? And so what ends up happening is last time, like a few days ago, I have an SDDM, right, to show you like the login screen, just because I want it to be pretty. You know, I'm a simple guy. I want the things to look pretty. I want them to be like, oh, this little rectangle, very pretty. Oh my god, the background is very cool, etc. I don't do like the rising that some people do, where they put like crazy stuff. I just want like a nice background in my login screen. I just want to be received by a decent login screen instead of a terminal login, right? Just because I like it more. I can see the clock, etc. And so I was having the problem that the main login was being displayed in the second monitor rather than the first one, right? I don't want that. I want the login to be in the main monitor, and then the second one have just the background, no login information or anything. Oh my god. The amount of setup required for that to happen was absolutely insane. Like, I had Hyperland, and then it's like, well, actually, your SDDM is completely separate from the first user instance of Hyperland, right? And then you're like, okay, how do I tell the SDDM that I want to display things in my main monitor? And it's like, well, actually, that is very much not that possible, because it can grab the config of who the primary monitor is from X11, or it can grab it from somewhere else. I'm saying a bunch of words that maybe don't make sense, right? And then it's like, well, you know, and then I tried looking at it, and then I found the variable somewhere in some scripts that say like primary something something something. It turns out that like apparently the thing is creating the exact same environment in both monitors. And so I'm like, what do you mean? So it doesn't know which one is the primary monitor. And I'm like, dude, this is such a simple thing, right? Like in Windows, I would just go to the monitors, click this guy, and set the primary. And that's it. I would not need to worry about anything else. In Mac OS, the same thing. In Linux, at least in Arch, oh my god. There was no real source of truth of which one was the primary monitor. Sometimes it would grab it from some weird file. Sometimes it would grab some environment variable. Turns out the SDDM wasn't even grabbing who the primary monitor was. And when I actually told it to grab it from somewhere, it turns out that it was running 2 instances of the SDDM. So it was insane. And like, since it was running 2 instances, it actually thought that both monitors were primary. And so like, and then it like, when you, because you identify a monitor by the index, right? You say like monitor index 0, monitor index 1. So instead of saying primary, I decided like, okay, let me see what the index of the monitors are. Turns out the monitors have the same index. This one has index 0, this one has index 0, according to the SDDM. Because it just runs different instances. And that's impossible until I discovered. So what I did was like separate, find a differentiating aspect for the monitors. And like the solution was that like, since it was running 2 instances at the same time, there was like one value that in this one was 0 because it was the first one to get set. And then the second one would try to also be 0 but couldn't, so it'd become -1. And so I said like, if this random variable we found in like this random place is equal to -1, then put the SDDM there. And so I ended up achieving what I wanted. But like taping it all together with like boogers and paper. Like, I'm so sorry for the expression, but like genuinely, it was such a weird odyssey. So that's an example of like a thing I don't like, where I would normally just say click set primary. Here it's just impossible. And like, if I ever move to a different PC, it's going to be hell on earth, because who knows what setting in some random file was holding up the entirety of my setup, right? Like, suppose I change my PC for something else, and then I try to do, I import my dot files and everything, and then like the SDDM thing doesn't work anymore, right? It's gonna be because it was some random file that I needed to edit at some point in time, And like now I'm gonna just not know where it is, not know what to do after like 5 years passed ever since I did that fix. Um, so yeah. And the other thing would be, I guess, the compatibility. There's like a bunch of software that doesn't ship for Linux. An example is this guy. This keyboard has like an application called IQ that is released by Corsair that allows you to edit the lights. Corsair just doesn't. They just don't give you the official application for Linux. So you have to install things that other people have created, which it's an advantage and a disadvantage. I feel it creates community because then there's some random guy that had the same issue. So they just created some AUR package for you to download and be able to play with your keyboard. Um, but yeah, I feel that's a problem. Maybe you should write down that workaround for the sheriff in the future. Yeah, I've written it down. I wrote it down somewhere. The problem is like there's always gonna be something that's like so minor that you're like, yeah, this is not gonna affect me in the future, and then like, you know. This seems random, but what's your opinion on Bun rewrite from Zig to Rust? I don't think I have much experience. Like, I am not as informed as I would like to be. I do know, like, I know of the rewrite happening, of them saying, no, this is just a little experiment, and then all of a sudden being like, oh yeah, we're changing, we're switching. Um, yeah, I don't remember the exact reasons why the switch happened because remember reading this like or hearing about this like a while ago. Um, yeah, I would need to be like a little more informed. I do remember it was related to Zig's AI contribution policy or something of that sort. Although, please correct me if that's not the case. Um, yeah, but yeah, that's all. Huh, all right. I think it's 2 p.m. Time. I think this is the perfect time to sort of end the stream because we've coded, we read the Bitcoin white paper, we should be proud of ourselves. Very good, we understood absolutely everything. So yeah. Oh wait, from last month, Bar is no longer purely open source project. No, they got a publisher. What a timing! I didn't play it for a year. No. Okay, W stream. Yo, W stream. Thank you. Okay, let's try and rate someone. Let's not forget about that. I feel it's good to rate people because then, you guys can keep watching some things that may be interesting. So let me go to the software and games category. Let me go to the coding scene. So is there somebody that you see, maybe it's interesting, maybe they do some stuff with C++, with Rust, preferably no AI because like, I feel one of the things that we have here in this channel is the no AI thing. MatClad! What do you mean can read MatClad? MatClad streams? What? He's on the Tiger Beetle channel. Really? Wait, where is it? I don't see it. MatClad! Oh, this one? Iron Beetle? Tiger Beetle? Is it this one? I imagine, right? Please confirm. Yes, I think. Okay, that's great. Oh my god. Bro, I did not know MatClad streamed. What the hell? Oh my god, dude, we're gonna raid MatClad. Wait, this is crazy. Raid. What is easier? Tiger Beetle. Okay. Alright, people. Tiger Beetle. Alright. Chat. Alright. See you guys. Bye bye. You have a nice day too. Strangers stand there. The strangers stand there. Oh no.